Good evening from NASA's Kennedy Space Center in Florida. I'm Stephen Clark, editor of spaceflightnow.com, and I want to welcome you to our live coverage of the Artemis 1 countdown here on Florida Space Coast. You're looking at a live view of NASA's Space Launch System vehicle perched on Launch Complex 39B tonight. At this point, the countdown is in a built-in hold at T-minus 6 hours and 40 minutes. This is a pre-planned stop of the countdown clock set to last 2.5 hours, and during this hold, teams here at the Kennedy Space Center will confirm their readiness to begin loading more than 3/4 of a million gallons of cryogenic propellants into the Space Launch System core stage and upper stage. That will consist of super cold liquid hydrogen and liquid oxygen that will be pumped into both stages of the vehicle on pad 39B, beginning shortly after midnight Eastern Time. Right now, we're not aware of any technical issues being worked in the countdown. Weather parameters also appear favorable at this time for the start of cryogenic tanking. The only weather constraints for tanking operations are associated with cold temperatures. That's not an issue tonight here in Florida. And lightning. There must be a less than 20% chance of lightning in the area around the spaceport for cryogenic tanking operations to begin. Right now, there are no thunderstorms in the immediate vicinity of the Space Center, but that constraint and those weather conditions will continue to be monitored by the launch weather officer over the course of the next couple of hours before cryogenic tanking begins in earnest, with the loading of liquid oxygen into the core stage first, followed by liquid hydrogen into the core stage. The upper stage will be loaded later into the countdown. This is the first flight of NASA's Space Launch System moon rocket. The vehicle stands 322 feet tall, roughly 98 meters in height, and it will be the most powerful launch vehicle to ever take off from U.S. soil, producing 8.8 million pounds of thrust at liftoff. The bulk of that thrust, 7.2 million pounds of that thrust, will come from the two side-mounted solid rocket boosters on each side of the orange core stage of the Space Launch System. There are 4 RS-25 liquid-fueled engines situated on the bottom of that core stage to produce another 1.5 million pounds of thrust or so for the climb to space. Those two solid rocket boosters will burn for about 2 minutes and 12 seconds before they exhaust their propellant and jettison to fall into the Atlantic Ocean. They will not be recovered on this mission. The core stage will burn its engines for about 8 minutes to reach a preliminary orbit around the Earth. And then the upper stage, the ICPS, as it's known, the interim cryogenic propulsion stage, will perform 2 burns with its RL-10 engine to send the Orion crew capsule on top of the Space Launch System on a trajectory toward the moon. Here's a view of the countdown clock here at the Kennedy Space Center. As you can see, it is at T-minus 6 hours, 40 minutes, and holding. This is a planned hold, not an indication of any technical issues being worked at this point in the countdown. The countdown clock will be resumed if everything is go for launch and go for cryogenic tanking at 1:23 a.m. Eastern Time, 5:23 a.m. UTC. So at this point in the countdown, the ground crew out at Launch Complex 39B, we believe, has evacuated the launch pad at this time. One of the early stages also at this point in the countdown is the changeover of purge air out at pad 39B from an air-based purge to nitrogen purge. This is designed to inert the area around the Space Launch System vehicle and the mobile launch tower to reduce the probability of any fires that may develop in the event of any propellant leaks or anything during the tanking operation. So once that gaseous nitrogen purge is established, that's one of the key milestones leading into the poll of the mission management team and the launch team here at the Kennedy Space Center to give their approval to start loading cryogenic propellants into the rocket in preparation for the launch opportunity tomorrow morning at 8:33 a.m. Eastern Time or 12:33 UTC. If you're just joining us, you're continuing to watch a live view of NASA's Artemis 1 vehicle on Launch Complex 39B at the Kennedy Space Center in Florida. As you can see, the countdown clock is holding at T-minus 6 hours and 40 minutes. This is a pre-planned hold. We're about 30 minutes now into this built-in hold. About 2 hours remaining in this pause in the countdown clock. But although the clock is paused, that doesn't mean the activity to prepare for the launch has taken a pause. Right now, the mission management team and the launch control team are meeting to verify that all parameters and all stations are go for tanking operations. If everything is go, then Launch Director Charlie Blackwell Thompson will issue her approval to start loading 750,000 gallons of cryogenic propellants into the Space Launch System. The core stage, which is 212 feet tall, makes up about 2/3 of the height of the Space Launch System, will be loaded with cryogenic propellants first. That'll be followed by loading of the interim cryogenic propulsion stage, the ICPS upper stage, with its propellant load. Everything continues to look good right now, weather-wise, and also no reports of any technical issues during the countdown. So we expect to see the start of propellant loading into the Space Launch System. That operation is expected to begin in less than an hour, with the chill down of the transfer lines leading from the liquid oxygen sphere out at pad 39B, the ground supply tank, up through the mobile launcher into the core stage. And that chill down operation is to thermally condition those transfer lines for the flow of super cold oxidizer into the rocket later in the countdown. You're now looking at a view of NASA's Space Launch System moon rocket provided by a NASA camera located on the eastern perimeter of Launch Complex 39B, looking at a side view of the Space Launch System moon rocket. You can see the NASA worm logo in red emblazoned on one of the two solid rocket boosters. A similar worm insignia is on the booster opposite this view. Now less than 9 hours until the opening of the Artemis 1 launch window Monday. Countdown remains on track at this point for a launch attempt at the opening of the window at 8:33 a.m. Eastern Time or 12:33 UTC. You can see in the upper right of this frame, the countdown clock is at T-minus 6 hours, 40 minutes and holding. This is a built-in hold that's lasting 2.5 hours. We're now about 45 minutes or so into this hold, which is scheduled to end at 1:23 a.m. Eastern Time. During this hold, teams, including the mission management team, chaired by Artemis 1 mission manager Mike Serafin, as well as the launch control team in the firing room of the Launch Control Center, led by Launch Director Charlie Blackwell Thompson, are polling their teams for a go or no-go to proceed into loading propellants on board the Space Launch System. This is a critical milestone in the countdown that NASA has rehearsed several times in the practice countdowns or wet dress rehearsals conducted in April and June. Those wet dress rehearsals were not problem-free. They revealed leaks and other issues, primarily with ground systems out at the launch complex area, as well as elsewhere on the Kennedy Space Center, that sites that support the launch operation. The fourth and final wet dress rehearsal back on June 20th did succeed in fully loading the Space Launch System's core stage and upper stage with propellants. But during that rehearsal, there was a leak in a quick disconnect fitting down near the bottom of the core stage in the tail service mast area. You can see that tail service mast area. That's the gray structure that sticks up above the mobile launch platform just to the left of the bottom of the core stage here. That's the apparatus that holds the transfer lines that flow cryogenic propellants, both liquid hydrogen and liquid oxygen, into the core stage. Those propellants flow from ground tanks out at pad 39B through the mobile launch platform, through that tail service mast, and then through an umbilical plate into the core stage. NASA officials believe that technicians have succeeded in closing that leak in that 4-inch quick disconnect line. But this line does flow hydrogen, which is chilled down to more than 400 degrees below 0 Fahrenheit. And when those components, that hardware is exposed to cryogenic temperatures, they contract. The shape and size of those components actually change. And the physical dimensions change when they're exposed to cryogenic temperatures. So there's really no surefire way to know whether the leak has been sealed and resolved until this hardware is again exposed to cryogenic temperatures, which we will see in the next couple of hours as the propellant loading process begins here at the Kennedy Space Center. We now have confirmation from NASA that the mission management team has pulled go to begin loading cryogenic propellants into the Space Launch System tonight. This meeting was chaired by the mission management team chairman, Mike Serafin. Next up will be the poll by Launch Director Charlie Blackwell Thompson over in Firing Room 1 of the Launch Control Center here at Kennedy. She will be polling her team in the next few minutes, according to the countdown schedule we have for their go or no-go to start tanking operations. As we wait an update on the status of tanking operations or tanking preparations here at the Kennedy Space Center, we're going to show an interview we conducted a few days ago with former NASA astronaut Doug Hurley. He is now a Senior Director of Business Development at Northrop Grumman. Northrop Grumman is the company that builds and supplies the solid rocket boosters for the Space Launch System moon rocket you see out on pad 39B. You can see one of those boosters here in this view with the NASA worm logo in red on the side of it. These boosters are comprised of steel casings that have been refurbished and reused from the Space Shuttle program, but these boosters have an extra segment for more power, more thrust to lift the Space Launch System off the ground. Northrop Grumman also supplies some structural components for the Space Launch System, as well as elements of the launch abort system, the crew escape system at the very top of the Orion spacecraft. Doug Hurley is a veteran of 3 space missions. He piloted 2 shuttle missions, including the last shuttle flight in 2011, and he was the spacecraft commander on the historic launch of the Crew Dragon spacecraft, SpaceX's first crewed mission to the International Space Station in 2020, which ended a nearly decade-long gap in U.S. orbital human spaceflight capability. So let's listen to former astronaut Doug Hurley's thoughts on the eve of the Artemis 1 mission. We're here with Doug Hurley, Senior Director of Business Development at Northrop Grumman, also a former NASA astronaut. Thanks for joining us. We're on the cusp of another big launch, which you have a lot of experience with. You were the pilot of the last shuttle flight. You were spacecraft commander for the Crew Dragon Demo 2 mission. You're not on this mission, you're not on the spacecraft, but it's another big day for the space program. Can you talk about your thoughts?
Yeah, I think you put it perfectly. It's just it's an exciting evolution of human spaceflight. You know, it's long overdue, in my opinion, for us to be going to the moon again. And then, you know, as we've heard, you know, using it as a stepping stone ultimately to Mars, which is just an incredible goal. So, yeah, it's just so neat to be back at Kennedy and to be ready, you know, for a launch in just a few days. I mean, an incredible amount of work has gone into this vehicle. You know, people have worked significant portions of their career already to get it to this point, which is just amazing. But we're here and we're ready to go. So can't wait for Monday.
You know, this is a test flight. We've been warned of the risks and what can go wrong. Do you think it's smart not to have a crew on this particular mission, or do you wish in the back of your mind that you were able to strap in, or one of your colleagues was able to strap into this test flight?
Yeah, great question. You know, my personal perspective as a test pilot, this is exactly what we should be doing. Build up approach to human spaceflight. End-to-end test of a vehicle. We're going to test it probably much more than we would with a crew on it. It's if we launch on Monday, it's a 42-day mission. The crewed flight for Artemis 2 is going to be significantly shorter. So just to get an understanding of how the hardware works from start to finish, and then be able to crawl all over everything when we get back, or look at the data, because obviously there's significant portions of the hardware that aren't designed to come back. But we're going to be able to get Orion back in the Pacific sometime in October, and get a good look at the capsule, at the heat shield, which is That's probably the biggest test objective for this flight, at least from what folks are saying, is testing that heat shield at those lunar re-entry velocities and making sure that it's safe, no issues for crew when we put them on them for the next flight.
A decade ago, I think the NASA Administrator Charlie Bolin kind of identified 3 big objectives for the agency over the 20-teens or that decade.
Yeah.
One was commercial crew, one was James Webb Space Telescope, the other was Space Launch System. And 2 of those have launched, and we're on the verge of the 3rd one. I just wanted to, if you look back at the end of the shuttle program, you were a part of that. You were a part of that decade of development leading up to this point. Just your perspective on how far the agency has come since July 2011.
Yeah, I can't tell you how much doubt I think a lot of us had, not only in the crew office, but just in general in the agency. At the end of 2011, what are we going to do? Where are we going? Now, notwithstanding, and I think it was even worse from a public standpoint, it's like, okay, you guys are done flying in space. It's like, well, no, we're still flying to the space station. We're still, flying crews, albeit on Soyuz rockets, but we're still doing that. But it really was a crossroads. And I give Charlie, of course, I flew with his son in the Marines, and I know Charlie really well and think the world of him. And it was a tough time, and nobody better than him to be at the helm of NASA and to point us in this direction, and then just see the wisdom that he had and the understanding that he had that we would get to this point literally 12 years later. We had a successful commercial crew flight. The first one was in 2020. We've done a number of those now. James Webb, by every possible measurable, it just really has done amazing. Just the pictures that picture of Jupiter that they showed the other day. It's just, and then just, from a personal standpoint, being part of Northrop Grumman and that success, having flown on DM2, and then now being part of SLS with the boosters, it's just, it's unbelievable. And, we owe it to Charlie, not to mention the nation, to make this a success.
You mentioned those boosters here. I was wondering if you could talk about what kind of performance they're going to provide, and some of the features of these boosters here.
Yeah, so a couple bits of trivia. My good friend Mark Tobias is the real expert on these boosters, but I'll just talk a little bit about the differences. So these are shuttle heritage boosters from the standpoint of the cases and a lot of the equipment. So these boosters, there are segments here that I flew on STS-127. I don't think there are any STS-135, but there's also an STS-124 booster part that my wife flew on. So we've got very good family history here. It's 5 segments, vice 4. So the 4-segment boosters were on shuttle. SLS requires bigger boosters, more oomph, so 25% more thrust, 1.6 million pounds of thrust per booster. So we've got an 8.8 million pounds of thrust at launch for the entire stack, and 7.2 of that is the boosters. So an incredible amount of power, but we understand the hardware. Obviously it's a little bit bigger, but we understand this. It's got an incredible amount of shuttle heritage, as I said. So we're excited to be, that first big lift into space for SLS and Orion, and we're looking forward to Monday.
I've seen a lot of shuttle launches. It had a kind of distinctive crackle from those SRBs.
I was just going to say that. The crackle is what I'm looking forward to hearing. I would guess you're going to still hear that because it really kind of overwhelmed the sound of the main engines, I thought, whenever I watched one in person. And so I'm expecting to hear that same very distinct crackle of that solid rocket propellant being burnt. So looking forward to it. And hopefully if the weather cooperates, we're going to be able to even see the separation on Monday. So 2 minutes and 6 seconds. And then a little bit more SLS booster trivia. I think it's 177 feet. So they're 25, 30 feet taller than what we had on shuttle. So it's amazing. Having saw the vehicle in the VAB, you get a sense of it here, but this is a huge distance between the top of the boosters, and whereas shuttle, the boosters were just kind of below the windows of the crew module.
Mm-hmm.
So it's amazing how huge this vehicle is.
Well, Doug, thank you for your time, and
you guys.
Good luck with the mission, and good luck with your new role at Northrop Grumman.
Thanks, Stephen. Really appreciate it.
That was Doug Hurley, former NASA astronaut, space shuttle pilot, Crew Dragon commander, talking about his thoughts on the Artemis 1 mission that you're looking at now live, a view of the Space Launch System from the top of the mobile launcher, looking down onto the Orion spacecraft. You can see the NASA and European Space Agency logos there on the Orion service module aeroshell, and those two solid rocket boosters from Northrop Grumman, those nose cones also visible near the bottom of this frame. As we reported a few minutes ago, the mission management team has given their go to proceed with propellant loading tonight. We're waiting on a final go from Launch Director Charlie Blackwell Thompson to begin the procedures to start loading super cold propellant into the Space Launch System out at Pad 39B. Here's a really nice view from NASA showing the top of the core stage, near the top of the core stage, and the top of the solid rocket boosters. The white curved area in the middle of the frame on the side of the core stage is the top of the liquid oxygen feed line. That's the line that flows liquid oxygen from the tank in the core stage down to the engine section. The core stage is made up of two tanks, a liquid hydrogen tank, which comprises the majority of the vehicle, the bottom part of the vehicle, and then at the top of the core stage is the liquid oxygen tank. Here you can also see the core stage intertank umbilical, which is one of several umbilicals leading out from the mobile launch tower connecting up to the Space Launch System that will be retracting at liftoff. They'll be swinging away from the vehicle when it begins its vertical climb off the pad to start the Artemis 1 test flight. The countdown continues, holding at T-minus 6 hours and 40 minutes. This is a pre-planned built-in hold. As I mentioned earlier, we're getting feeds now from NASA cameras out at Launch Complex 39B. This particular camera is doing a survey, scanning back and forth across the vehicle. This appears to be pointing in the general area of where the launch vehicle stage adapter, that's the conical shaped structure that connects the core stage with the upper stage. That's the orange part of the rocket that you're seeing here, and this is one of the umbilicals that connects up to the launch vehicle. And there appears to be an access cover there on the launch vehicle stage adapter. The engine nozzle for the upper stage is actually located within the volume of that launch vehicle stage adapter. You can see a really tight shot of some of the foam insulation. That's the orange material covering the outer skin of the core stage and the launch vehicle stage adapter on the SLS moon rocket. And there's a wide shot again from a camera located at the top of the mobile launch tower, looking down on the Space Launch System. We're still waiting on the final go for cryogenic tanking from Launch Director Charlie Blackwell Thompson. We haven't heard confirmation of that quite yet. The mission management team did give a go for tanking earlier in the countdown. The latest update from NASA indicated they're working a couple of issues right now. One of them involves a communications issue with the Orion spacecraft. This is not a constraint for tanking. However, it would be a constraint for entering the terminal countdown and a constraint against launch today for the Artemis 1 mission. So engineers are evaluating that communications issue and hope to get that cleared in time for the launch window this morning, which opens at 8:33 a.m. Eastern Time or 12:33 UTC. The team was also discussing an observation or material on the tail service mast umbilical. That's the structure that connects the fluid lines, the propellant loading lines, from the mobile launch table into the core stage of the Space Launch System. There are some thunder showers in the vicinity of the Kennedy Space Center, but these are not expected to be a constraint for tanking. The main concern for tanking would be if there's a greater than 20% chance of a lightning at the start of tanking operations. There's also a temperature constraint for cold temperatures that could prevent tanking, but that's not a concern. It is late August in Florida, so the temperature constraint is not a concern this morning for tanking. Lightning could be a concern, but the latest update we heard from NASA indicates that the launch team does not expect that to be an issue for tanking. Here's a cool view, a wider view of the bottom part of the core stage of the Space Launch System. You can see it sitting on the mobile launch platform out at Launch Complex 39B. Two of the 4 RS-25 core stage engines also visible here. And the flame trench is also easily visible beneath the mobile launch platform. That's the basin that's dug out underneath the launch platform. That's where the hot gas from the solid rocket boosters and the core stage engines will be directed during the ignition sequence and launch. This Artemis 1 test flight will actually be the first launch from Pad 39B since October of 2009, when NASA's Ares 1X suborbital test rocket took off from this pad. The latest update from NASA indicates that the launch team is monitoring some thunderstorm activity that's just offshore from the Kennedy Space Center. These storms contain lightning, which is a constraint for the start of tanking operations. However, it apparently is not a constraint for the initial steps to prepare for cryogenic tanking. That includes the chill down of the liquid oxygen transfer lines from the liquid oxygen storage sphere out at pad 39B, leading up to the launch deck itself and through the mobile launch platform into the core stage. These transfer lines will be chilled down or thermally conditioned by pumping very small amounts of supercold oxidizer through those lines to condition those elements, those hardware elements, for the shock, essentially, of the flow of supercold propellants as the filling of the core stage would begin later this morning, first in a slow fill mode and then a fast fill mode. So those chill down preparations are getting underway right now. However, the actual loading of cryogenics, liquid oxygen, into the core stage is not occurring quite yet. It's not scheduled to begin quite yet, but the stormy weather near the Kennedy Space Center is now being monitored by the launch team to ensure that the risk of lightning is not too high to begin cryogenic loading, the actual flow of oxidizer, liquid oxygen, into the core stage. Here's a cool view of one of the cameras out at pad 39B panning up and down the core stage of the Space Launch System. The constraint for tanking is that there must be a no greater than 20% chance of lightning in the launch pad area to begin flowing cryogenic propellants into the Space Launch System. Continuing to watch live views of NASA's Space Launch System moon rocket on Pad 39B here at the Kennedy Space Center in Florida. If you're just joining us, my name is Stephen Clark. I'm the editor of spaceflightnow.com, and I'm going to be joining you throughout the remainder of the countdown, as well as the Artemis 1 mission's climb into space this morning. The start of cryogenic propellant loading into the Artemis 1 moon rocket is currently on hold due to some thunderstorm activity just off the coast of Cape Canaveral. Those storms are actually moving toward the Kennedy Space Center and moving in the general direction of the Launch Complex 39B area. And there is a constraint, a weather rule that says NASA cannot load cryogenics into the Space Launch System if there's a greater than 20% chance of lightning. And these storms do contain lightning, according to the launch weather officer, who has been briefing the launch director on the status of the evolving weather situation. This camera out at Launch Complex 39B that we're getting the NASA feed from is now zooming in on parts of the Orion spacecraft. You can see the NASA and European Space Agency logos there on the outer shell. That's the aeroshell that protects the Orion spacecraft during the initial 3 minutes or so of flight through the atmosphere. And then at the top, the curved portion of the top of the Orion spacecraft is the crew module. And then below that, where the NASA meatball and ESA logo is the service module. Below that, with the checkered pattern, is the Orion stage adapter. And then directly below that is the interim cryogenic propulsion stage, or upper stage, produced by United Launch Alliance. The ICPS upper stage is based on ULA's Delta IV Heavy upper stage that flies on ULA's Delta IV Heavy rocket program. And then the orange part of the rocket below the white band of the upper stage is the launch vehicle stage adapter. That's the structure that connects the upper stage with the core stage. Those two stages are at different diameters, so the LVSA, as it's called, the launch vehicle stage adapter, actually tapers into the smaller diameter of the upper stage. Zooming in now on that upper stage, you can see some of the insulation on the outer skin of one of the propellant tanks on the upper stage there. And those umbilicals also visible leading from the mobile launch tower. Those lines connecting up to the upper stage as well as the service module of the Orion spacecraft. Those lines feed electrical, telemetry data, fluids, and conditioned air and other commodities into the vehicle. Panning down here, you can see the launch vehicle stage adapter connecting to the top of the core stage. And now we're panning down the core stage, which measures 212 feet tall, about 28 feet in diameter. There's one of the nose cones on the right there of one of the two solid rocket boosters. NASA says that the weather conditions here at the Kennedy Space Center continue to violate the constraint for lightning to begin cryogenic tanking of the Space Launch System. So preparations to load cryogenic propellants, liquid hydrogen, liquid oxygen, into the core stage of the SLS moon rocket have been completed. That rocket is now ready to receive its more than 750,000 gallons of cryogenic propellants. But the weather conditions are not permitting that to start at this time. So we are in a weather hold right now here at the Kennedy Space Center. The weather rule states that there cannot be a greater than 20% chance of lightning in the area around the launch pad during the initial phase of tanking operations. And right now there is a greater than 20% chance of lightning in the area during the first phase of tanking. So cryogenic loading is not starting right now. There is a lightning in some of the thunderstorm cells that are just off the coast of Cape Canaveral, just to the southeast of the launch pad, and those storms are moving toward the Kennedy Space Center at this time. The countdown remains in this built-in hold. This is a planned hold at T-minus 6 hours and 40 minutes. The timeline going into the countdown called for the hold to be released and the clock to resume at 1:23 a.m. Eastern Time, or 5:23 UTC. NASA does have a little bit of wiggle room in the countdown. There's a little bit of flexibility in the timing of the tanking operation, and there is a 2-hour launch window from 8:33 a.m. to 10:33 a.m. Eastern. That's 12:33 to 14:33 UTC. So even if the tanking operation does get a late start, there is still a chance for the countdown to proceed this morning down to a launch opportunity for the Artemis 1 lunar test flight. In this live view of Launch Complex 39B, you can see some rain falling on the Space Launch System. This is one of the showers that's moving on shore from the Atlantic Ocean over the Cape Canaveral area this morning. Some of these showers contain the threat of lightning, which is what's holding up the start of cryogenic tanking of the Space Launch System moon rocket. The rain itself is not an issue, but here's an interesting view of the rain falling on the Orion spacecraft and the Space Launch System out at Pad B. The latest update from NASA is that there are some encouraging signs with some dissipation of some of these showers and storms moving on shore at the Kennedy Space Center. Right now, there's a 30% chance of lightning within the 5 nautical mile circle around the launch pad. That needs to get down below 20% for cryogenic tanking to proceed this morning. The weather team here at the Kennedy Space Center continues to track these scattered thunder showers that are streaming from the southeast to the northwest. That's the general direction of these storms as they move on shore from the Atlantic Ocean waters over the Cape Canaveral area. There is another storm cell that did just pop up just to the northeast of the Launch Complex 39B area. We have seen some rainfall out at the pad. It continues to rain out there right now. The rain is not the issue, though. The lightning is the problem. The storm cell just to the northeast of the pad is currently within the 5 nautical mile ring around the pad. That's the area of concern, where there must be a less than 20% chance of lightning within that 5-mile ring around the pad during the first hour of tanking operations on the core stage. There's a similar rule in place for the first hour of tanking on the upper stage, which occurs later in the countdown, a few hours down the road. So the cryogenic tanking continues to be on hold as the weather team monitors the evolving weather situation here on Florida's Space Coast. As you can see, it's continuing to rain out at pad 39B. Those are raindrops bathing the Space Launch System and the Mobile Launch Platform deck in water, as we're now just past the 1 a.m. hour here on the east coast of Florida. We expected the expected time for the start of slow fill of the core stage liquid oxygen tank was to be about 4 minutes from now. It does not appear like it's likely to start on time, but there is a 2-hour launch window that the launch team can work with, so there's still some time to wait for this weather to clear, the threat of lightning, most importantly to clear out of the area to allow this tanking operation to proceed to begin loading fuel and oxidizer into the Artemis 1 moon rocket. Hello again from NASA's Kennedy Space Center in Florida. We've just heard from NASA's launch control team that the cryogenic loading preparations are now beginning, with the chill down of the liquid oxygen transfer lines going into the core stage of the Space Launch System. This chill down procedure thermally conditions these transfer lines leading from the ground storage sphere up to the mobile launch platform. This activity is running nearly an hour behind schedule at this point. So it remains to be seen whether the team can make up that time or if this might impact the target launch time, which was 8:33 a.m. at the opening of the 2-hour window, 8:33 a.m. Eastern time. But there is a 2-hour window in the event that the 8:33 time is not attainable due to this delay in the tanking operation. The countdown clock has now resumed after this 2.5-hour built-in hold at T-minus 6 hours and 40 minutes. This was a built-in hold that allowed the launch team to get ready for cryogenic tanking. The next planned hold in the countdown is not until T-minus 10 minutes. That'll be a planned 30-minute hold. At that time, Launch Director Charlie Blackwell Thompson will poll her team for the final go to enter the terminal countdown sequence. Again, just to recap where NASA is in the Artemis 1 countdown, the chill down operation to thermally condition the liquid oxygen transfer lines leading from the liquid oxygen storage tank at the pad up to the mobile launch platform and into the core stage of the Artemis 1 rocket. Those lines are now being chilled down, thermally conditioned by flowing a little bit of liquid oxygen through those lines to condition those components and those elements for the flow of liquid oxygen into the core stage when that operation begins later in the countdown. NASA says it's likely that the launch time may have to be shifted somewhat within the 2-hour launch window due to this delay in the start of cryogenic tanking. That remains to be seen. That decision will be made later in the countdown, according to NASA. Continuing to rain out at the launch pad, but with this lightning threat diminished, preparations to begin loading 755,000 gallons of cryogenic propellants is now underway at the pad. NASA reports that the core stage liquid oxygen transfer line chill down, this is the line that flows the cryogenic oxidizer from the storage tank at the pad into the mobile launcher and ultimately into the rocket, has completed the chill down procedure, so that thermal conditioning is complete. And the team is now moving into liquid oxygen chill down on the main propulsion system on the Space Launch System. This involves actually flowing a little bit of liquid oxygen into some of the engine compartment plumbing to condition those lines. And that will be followed, according to the timeline going into the countdown tonight, about 40 minutes from now, nominally, would be the start of the slow fill of liquid oxygen into the core stage. As NASA prepares to start loading cryogenic propellants into the Space Launch System moon rocket, here's a breakdown of what will be loaded into the vehicle this morning. The total propellant capacity, the liquid propellant capacity for the Artemis 1 moon rocket is 755,000 gallons. 733,000 of those gallons are on the core stage, or first stage of the vehicle, 22,000 gallons on the upper stage. And here's a breakdown. The largest tank by far that will be loaded during this countdown is the core stage liquid hydrogen tank. This liquid hydrogen is chilled to about minus 423 degrees Fahrenheit. 537,000 gallons of liquid hydrogen will be loaded into the core stage. The other tank on the core stage is the liquid oxygen tank, 196,000 gallons capacity there. That's the first of the 4 propellant tanks that will be filled during this countdown. Once the core stage is nearing the end of its propellant loading process, the attention will turn to the upper stage. This is the much smaller stage, the much smaller element of the Space Launch System, produced by United Launch Alliance. It's based on the upper stage that flies on ULA's Delta IV Heavy rocket, a flight-proven design. 17,000 gallons of liquid hydrogen will flow into that upper stage, and 5,000 gallons of oxidizer will also be loaded into the upper stage. The core stage is powered by 4 RS-25 main engines to consume that 733,000 gallons of propellant on the first stage. Here is a view of those 4 engines. 2 of the engines on the left are readily apparent in this view. If you look closely, you can see the other 2 engines on the right with the thermal insulation or heat shield surrounding their interface with the bottom of the engine section, the bottom of the airframe, so to speak, of the core stage. The upper stage is powered by a single RL-10 engine. If you're just joining us, you're looking at a live view of NASA's Space Launch System moon rocket on Pad 39B. NASA's launch team is in the early stages of preparing to load cryogenic propellants into the core stage of the Artemis 1 moon rocket. As we mentioned before, this operation is running about an hour behind schedule right now due to some thunderstorm activity that moved through the area, bringing the threat of lightning within the 5-mile ring around the launch pad. that threat of lightning has diminished, allowing the cryogenic tanking operation to proceed. But it is running about an hour behind schedule. NASA's launch team hopes they can make up some of the time that they lost this morning before starting tanking operations. But it is possible that the launch time will have to be pushed back to sometime later in the 2-hour window. The launch window opens at 8:33 a.m. Eastern Time, 12:33 UTC. That's still the official target launch time. And the window extends for 2 hours this morning here at the Kennedy Space Center. NASA's Artemis 1 countdown clock is passing T-minus 6 hours, 8 minutes, and counting. Preparations for loading liquid oxygen into the core stage are continuing at this time. On the left-hand side of your screen, you can see some of the major elements of the Space Launch System here labeled in this graphic from NASA. And on the right, you're looking at a live view of the rocket itself, live at Pad 39B. The Space Launch System stands 322 feet or 98 meters in height. This is known as the Block 1 crew configuration of the Space Launch System. NASA has plans down the road, beginning with the 4th Space Launch System flight, called Artemis 4, to upgrade the upper stage of the vehicle, replacing the interim cryogenic stage, which has a single RL-10 engine, with an exploration upper stage with 4 RL-10 engines powering that stage to allow the rocket to lift heavier cargo to the moon and beyond. In that configuration, with the exploration upper stage, the Space Launch System will be able to actually launch a crew capsule along with cargo on a single mission, whereas in the Block 1 configuration, the Space Launch System is only able to carry the crew capsule essentially on a trajectory toward the moon. The main element of the rocket is the core stage, which comprises about 2/3 of the height of the vehicle. The core stage was built by Boeing at the Michoud Assembly Facility near New Orleans, Louisiana. It's derived from the Space Shuttle external tank, a similar design built in the same factory as the shuttle external tank was constructed in. But this is a new development, though, with the core stage. Instead of having no engines on it, as the external tank had, the core stage of the Space Launch System has actually the 4 RS-25 engines mounted on the bottom. So the entire engine section down at the bottom with those 4 engines is new and was not part of the Space Shuttle external tank. It's also much taller than the shuttle external tank. The 2 solid rocket boosters are 5-segment motors produced by Northrop Grumman. They are also derived from the Space Shuttle solid rocket boosters, which were 4-segment motors. These are taller and produce more thrust than the shuttle solid rocket boosters. Above the core stage is the launch vehicle stage adapter. That's the conical structure that connects with the interim cryogenic propulsion stage with its single RL-10 engine. The ICPS, or upper stage, was built by United Launch Alliance, and the RL-10 engine was built by Aerojet Rocketdyne. And at the top of the vehicle is the Orion spacecraft, made up of 3 main components: the launch abort system, which sits on top of the vehicle. That's the system that would be used to help the crew and capsule escape from the Space Launch System in the event of an emergency during the launch sequence or a failure of the rocket. The crew module is built by Lockheed Martin. This crew module is capable of accommodating a crew of 4 astronauts in deep space for up to 21 days of standalone operations, longer durations possible in the future when the Orion spacecraft is expected to eventually dock with the Gateway space station that NASA plans to construct in orbit around the moon. Below the crew module is the service module, which was built by Airbus Defence and Space as part of a contract with the European Space Agency, NASA's partner on the Orion and Artemis program. So there are the main components of the Space Launch System, which is awaiting an opportunity to fly as soon as this morning from the Kennedy Space Center on its inaugural test launch. This maiden flight of the Space Launch System has been a long time coming. This rocket has been in development for about a decade, a little more than 10 years now, and has cost more than $20 billion to develop to date. And this unpiloted test flight is designed to pave the way for future missions on the Space Launch System and Orion spacecraft carrying astronauts. As you can see, the countdown clock is still ticking, T-minus 6 hours, 3 minutes, and 10 seconds, and counting. NASA has just confirmed that liquid oxygen is now flowing into the core stage of the Space Launch System moon rocket. This is a tank that will contain 196,000 gallons of liquid oxygen. The liquid oxygen, also known as LO2 or LOX, is chilled to nearly 300 degrees below 0 Fahrenheit and is now loading into the core stage in slow fill mode. That will transition to fast fill after roughly 20 to 30 minutes, according to the planned countdown timeline. That's when it will transition to fast fill. Here's a really nice view from one of the launch pad cameras showing the 4 RS-25 engines at the base of the Space Launch System core stage. This camera view now zooming into one of the attachment struts, one of the aft connecting points between one of the solid rocket boosters and the core stage. This is a NASA camera, so one of the members of the NASA launch team is actually controlling this view. So we're kind of along for the ride as this camera pans around various parts of the Space Launch System, but it's a good opportunity to get a really good up-close view of various parts of this huge rocket, 322 feet tall. The core stage alone is 28 feet in diameter. This shows the liquid oxygen feed line that runs the height of the core stage from the liquid oxygen tank, which is near the upper part of this core stage structure, down to the engine section. So in flight, that pipe there will actually handle the flow of liquid oxygen from the tank at the top of the core stage, rushing down the length of that booster stage down to the engine section to feed those 4 RS-25 engines. The entire core stage is covered in insulating foam to help maintain cryogenic conditions inside those propellant tanks to prevent boil-off of propellants. During the shuttle era, the space shuttle era, this orange foam was used to also help prevent ice from building up on the external tank of the shuttle. That's not as much of an issue for the Space Launch System because there's no shuttle orbiter hanging off the side of the tank in this case. NASA in those days was concerned with ice and falling off of the external tank and impacting the heat shield tiles on the shuttle. That is not a concern with the Space Launch System. That's one of the design drivers of a vehicle like this, is to not have any threat of debris or ice that could impact the heat shield of the spacecraft. The spacecraft is on top of the rocket in this case, as it was back in the Apollo era. As NASA continues this slow fill mode of loading liquid oxygen into the core stage, you can see here on the feed line some vapors from one of the joints. This is normal as this cryogenic propellant, supercold propellant, loads into the core stage. It's actually flowing up that feed line into the core stage tank, a reverse course of the flow that the liquid oxygen will take in flight as it flows down into the engines. NASA has just confirmed that the liquid oxygen load has transitioned to fast fill mode. This is our increase in pump speed, doubling the pump speed to double the flow of liquid oxygen into the core stage. This occurs as the core stage liquid oxygen level surpasses or passes the 5% full mark, and the fast fill mode will continue until it reaches the 95% point, and then the slow fill or topping mode will take over for the final 5% to get up to the 100% flight level for the core stage liquid oxygen tank. It'll take about 3 hours or so per the nominal timeline to fully load the liquid oxygen tank. The next major step into this countdown operation will be the transfer line chill down for the liquid hydrogen system. This is a similar process that we saw for the liquid oxygen system about an hour or so ago, a little more than an hour ago now. And once that chill down is complete, we'll see the start of slow fill for liquid hydrogen on the core stage. We've just heard a report from NASA that the liquid hydrogen tank on the core stage is now being loaded in slow fill mode. So this is the second of the 4 propellant tanks to begin loading this morning. And by far, it is the largest in volume to be filled during the Artemis 1 countdown. 537,000 gallons of liquid hydrogen will actually be flowed into the core stage over the course of the countdown this morning. This loading of the hydrogen tank will take about 2 hours. The Artemis 1 launch countdown is now at T-minus 5 hours and 21 minutes. At this point in the countdown sequence, the core stage of the Space Launch System moon rocket is being loaded with liquid oxygen. That liquid oxygen is being pumped into the vehicle in what's called fast fill mode. The liquid oxygen tank sits on top of the liquid hydrogen tank inside the core stage of the Space Launch System vehicle. Meanwhile, the liquid hydrogen tank, which is the tank that is the lowermost tank inside the core stage, below the liquid oxygen tank, is being filled with its fuel load in what's called slow fill mode. That will transition to fast fill in a few minutes' time, we believe, if everything is on schedule. We're cycling between different views that NASA is providing us from engineering cameras out at Launch Complex 39B. Really nice views of the Space Launch System here on Florida's Space Coast. The launch window opens in less than 6 hours at 8:33 a.m. Eastern Time or 12:33 UTC. The cryogenic tanking timeline is running between 45 minutes to an hour behind schedule at this point due to a late start caused by the threat of lightning in the Kennedy Space Center area. NASA reports that the liquid oxygen tank on the core stage is now at the 14% full mark. The liquid hydrogen remains in slow fill mode. That will be transitioned to fast fill once the LH2 level reaches 5% inside the core stage. Now, T-minus 5 hours and 15 minutes, we're continuing to monitor the Artemis 1 countdown. We have 3 different Artemis patches available for purchase on the Spaceflight Now store at shop.spaceflightnow.com. At top left is the Artemis program patch. Below that is the Artemis 1 mission patch for the mission launching today. And then below that is a commemorative Artemis patch. These three patches are available for purchase in our Spaceflight Now store at shop.spaceflightnow.com. We hope you'll go there and check out these patches as well as other offerings in our store. Contributions through our store help support our coverage of launch activity and launch operations and help us bring you streams like this one. Here's a really nice view looking down the length of the core stage of the Space Launch System. If you look closely, you can see some of the vapors venting out of the engine section at the base of the core stage as liquid oxygen and liquid hydrogen, both stored at cryogenic temperatures, flow into the main stage of the Space Launch System. The 2 solid rocket boosters are visible on each side of the orange core stage. Those 2 boosters, supplied by Northrop Grumman, already have their solid propellant pre-packed inside their steel casings. That solid propellant was cast several years ago, actually, at Northrop Grumman's booster fabrication and refurbishment site in northern Utah. And then those segments were transported down to the Kennedy Space Center on a train in mid-2020. And NASA ground teams began stacking those boosters in late 2020 inside the vehicle assembly building. Those were the first elements of the Space Launch System to be stacked onto the mobile launch platform inside the high bay of the vehicle assembly building. Those boosters are sitting on hold-down posts, although they're not actually hold-down posts because there are no hold-down bolts holding the Space Launch System onto the deck of the mobile launcher as there were in the shuttle program. Instead, the rocket is basically just set atop pedestals, and then the weight of the rocket keeps the vehicle stable during rollout and during the launch operations out at Pad 39B. The fully fueled rocket will weigh about 5.75 million pounds. So it's quite a heavy vehicle, and just the weight of that vehicle keeps it firmly onto those pedestals until ignition of the 2 solid rocket boosters, which will produce 7.2 million pounds of thrust. Combined with the main engines, that's 8.8 million pounds of thrust to propel the rocket off of the pad. Here's a view of the Orion spacecraft inside of its aeroshell on top of the Space Launch System with the U.S. flag there. The Orion is covered up in this aeroshell to protect the spacecraft from aerodynamic forces during the first few minutes of flight. That aeroshell will actually be jettisoned about 3 minutes after liftoff to reveal the spacecraft inside. Here you see the NASA worm logo on the Orion spacecraft. The worm logo is also emblazoned on the boosters, the two solid rocket boosters on each side of the core stage of the SLS moon rocket. And there's the NASA meatball logo and the European Space Agency insignia on the aeroshell outside of the European-built service module on the Orion spacecraft. This is a NASA engineering camera under the control of one of the members of the Artemis 1 launch team, doing a video survey of various parts of the Space Launch System and the Orion spacecraft as they await a launch opportunity later this morning, a 2-hour window that opens at 8:33 a.m. Eastern Time, 12:33 UTC. And right now the vehicle is being loaded with liquid oxygen and liquid hydrogen in parallel into the core stage. The upper stage will be loaded a little bit later in the countdown. We expect that to begin in a little more than an hour, closer maybe to an hour and a half from now, if the countdown remains on its present track. There's a view of the launch vehicle stage adapter with one of the umbilicals connected to it on the left. The orange material you see painted, or not painted, but on the outer skin of the core stage and the launch vehicle stage adapter is a spray-on foam insulation. It's a thermal insulator to help keep temperatures inside the propellant tanks at cryogenic levels, at the proper cryogenic temperatures for these propellants at minus 423 degrees Fahrenheit for liquid hydrogen, roughly minus 297 degrees Fahrenheit for liquid oxygen. And here's a view down at the bottom of the core stage. You can see some of the vapors, if you look closely, every now and again from the boil-off of propellants. The propellants are, again, as I've mentioned, at cryogenic temperatures to remain in a liquid state, but it is warm here in Florida. And those propellants naturally boil off throughout the countdown and transition to a gaseous state. So that's often what you're seeing when you see vapors out at a launch pad, really any launch pad that has a cryogenic propellant, is you're seeing either condensed air or vapors, gaseous vapors from the boil-off of propellant. At the very top of this screen, I'll draw your attention to the launch abort system. You can see some of the nozzles there of the launch abort system. That's the system that would actually pull the Orion spacecraft away from a failing launch vehicle in flight if necessary, if the Space Launch System ran into a major problem after liftoff, or even while it's on the pad during the terminal countdown phase. That abort system is capable of pulling the Orion spacecraft off the top of the rocket and essentially saving its occupants, saving the crew that would be on board for future Artemis missions. On this particular flight, Artemis 1, this is an unpiloted test flight. There are no astronauts on board the Orion spacecraft this morning. So the launch abort system is only partially active. The abort motor, which is the large motor that would quickly pull the entire spacecraft away from the rocket in the event of a failure, is inert on the Artemis 1 mission. That's a cost-saving measure because there are no astronauts on board, so that system is not necessary for safety of the crew this morning. The jettison motor for that launch abort system tower is active and loaded with propellant because the jettison motor is required to actually pull that aeroshell off the Orion spacecraft roughly 3 minutes or so after liftoff. We'll see that tower jettison, and that jettison motor inside that tower is actually the system that will pull the entire needle nose shaped launch abort system away from the spacecraft. We just heard an update from NASA's launch control team that they have stopped flow on the liquid hydrogen system. Liquid oxygen continuing to flow into the booster or the core stage at this time. We're not sure why they stopped the flow of liquid hydrogen into the core stage. At last report, that was at 7% full on the liquid hydrogen tank of the core stage. NASA has provided another update on the status of the countdown. The launch team has detected an indication of a hydrogen leak in the area of the tail service mast umbilical. This is the structure that actually connects at the base of the core stage with the mobile launcher, and the propellants, liquid hydrogen and liquid oxygen, flow into the rocket through this interface. Here's a great view of the tail service mast umbilical area from when the mobile launcher was inside the vehicle assembly building. This picture was actually taken last year during a media tour of the vehicle assembly building during stacking of the Space Launch System. On each side of this image, you see the two solid rocket boosters for the Artemis 1 mission, which were already stacked at this time. But the core stage was not stacked at this time. It had not yet been delivered to the Kennedy Space Center for stacking. So you can see here the two tail service mast umbilicals in the center of your screen. One is for liquid hydrogen, one is for liquid oxygen. And this has been a key point that's been monitored throughout the wet dress rehearsal campaign for the Artemis 1 mission over the course of the last few months. And we just heard from NASA a few moments ago that the launch team has detected indications, at least, of a hydrogen leak associated with the liquid hydrogen loading interface, which is at the tail service mast leading into the core stage. So that's why the loading of hydrogen has been halted at this time. Liquid oxygen continues to flow into the core stage, up through that feed line into the liquid oxygen tank on top of the core stage. At last report, a couple of minutes ago, that was 30% full. There is a constraint that the liquid oxygen tank cannot surpass 50% full when there's not enough liquid hydrogen basically in the stage below it, in the tank below it rather. So if the liquid hydrogen stop flow status continues, if they're not flowing liquid hydrogen into the rocket, the liquid oxygen tank will not be able to get past the 50% loaded point. And just a reminder, the fuel loading process started nearly an hour behind schedule this morning due to some thunderstorms and the threat of lightning. And now the tanking process, at least with liquid hydrogen, is now falling further behind schedule as the team evaluates this potential leak that's been detected in the tail service mast umbilical. So the latest update from NASA is that the launch team is actually going to let the pressures inside the so-called purge can area near the in the tail service mast umbilical go back to a stable pressure, essentially, to anything that may have leaked out when they went to fast fill mode on the liquid hydrogen tank can disperse, and then they'll try one more time to go back into slow fill and then fast fill. And at that transition point from slow fill to fast fill, when the flow rate of liquid hydrogen into the core stage increases roughly by a factor of 10 during that transition, is when the launch team detected this sign of a hydrogen leak in the tail service mast umbilical. The TMSU, or tail service mast umbilical, is circled here. There's one for liquid hydrogen, one for liquid oxygen that flows, that transfers those propellants from the ground systems out of the pad into the vehicle itself. So that element is circled here. This is a similar area, roughly the same area on the tail service mast umbilical that engineers found a hydrogen leak in during a wet dress rehearsal back in April. The teams at that point had rolled back the Space Launch System to the vehicle assembly building, made a repair to this area, rolled it back to the pad again in June, and ran through a practice countdown on June the 20th. And there was no recurrence of a leak in this particular area during that practice countdown on June the 20th. That allowed the team to fully load the core stage with propellants during that countdown dress rehearsal. There was another hydrogen leak found elsewhere in the system during that wet dress rehearsal in a quick disconnect in a bleed line that leads into the engine compartment. But that was an unrelated leak to this particular leak in the purge can area of the tail service mast umbilical, the hydrogen side of the tail service mast umbilical. So the NASA launch team is going to give it one more try to get back into slow fill, resume the flow of liquid hydrogen into the core stage, which is now boiling off in the warm ambient air here in Florida, and then transition into fast fill to see if they see this evidence of a leak crop up again. This will also help, if there is a leak, help to determine where the leak might be, help the troubleshooting effort to try to eventually go in and repair that leak. Here's a view from one of NASA's engineering cameras showing the tail service mast umbilical, the connections to the bottom of the core stage, the engine section essentially, where the liquid hydrogen and liquid oxygen actually flows into the core stage of the SLS moon rocket from the mobile launch platform. On the right is the, on the right was the hydrogen umbilical. That's the area of interest right now. Here's another shot taken inside the vehicle assembly building during a media tour last year before stacking of the core stage. You can see the two SRBs on each side here. And in the middle is the spiderweb-like structure apparatus of the tail service mast umbilical with all those lines that will lead into the core stage. On the left here is the hydrogen umbilical. On the right is the oxygen umbilical. So the hydrogen umbilical is the area that's currently under analysis as the launch team troubleshoots this potential hydrogen leak that's been discovered in the purge can area. That's an enclosure that closes up the connection, the actual line connection, the fluid connection between the tail service mast umbilical and the rocket itself. And the tail service mast umbilical here is labeled in this view from the launch pad, this live view from pad 39B. At this time, even if this leak was somehow resolved, the countdown timeline is running about 90 minutes or so behind schedule, maybe just shy of 90 minutes after the 1 hour delay in the start of propellant loading, and then this troubleshooting action involving this potential leak. Here's another shot of the base of the core stage. This is on the side opposite of the tail service mast umbilicals. You can see at the very bottom of the frame the tops of the engine nozzles of the 4Rs-25 core stage engines. Each side of the core stage are the two solid rocket boosters. On the left side of your screen, that dark gray charcoal colored structure is actually a so-called rainbird for the sound suppression water system. It's one of multiple rainbirds that flow water onto the launch platform deck for acoustic suppression during liftoff. As the countdown clock continues to move at T-minus 4 hours and 15 minutes, the cryogenic tanking operation, at least on the liquid hydrogen side, is on hold again. The launch team, after detecting signs of a leak, resumed the slow flow of liquid hydrogen into the core stage, and then plan to transition that to fast fill mode to see if that signature of a leak recurred during that transition. But the flow of liquid hydrogen has again been stopped due to what NASA has called an overpressure alarm. So liquid hydrogen, after a brief resumption of flow, has stopped flowing into the core stage again. You're watching now a view of the liquid oxygen feed line on the outside of the core stage. Liquid oxygen is flowing up that feed line into the liquid oxygen tank near the top of the core stage. The plan forward for the Artemis 1 launch team is to once again try to resume the flow of liquid hydrogen into the core stage. That overpressure alarm that caused the stop flow on the second attempt to flow liquid hydrogen into the core stage seems to have been caused by a line that got too warm during that stop flow event. Without the cryogenics flowing through that line, the line got too warm, and when the flow resumed, there was an overpressure alarm. So the launch team is now doing what they call a manual chill down of that line to get it back to the proper thermal condition to safely resume flow of liquid hydrogen into the core stage. Again, this resumption of liquid hydrogen flow is all to is an attempt to get past the point where a little earlier in the countdown the team detected signs of a hydrogen leak in the tail service mast umbilical. That occurred around the time that they transitioned from slow fill mode to fast fill mode, when the flow of liquid hydrogen increases tenfold to more rapidly fill up the liquid hydrogen tank on the core stage, which contains or will contain 537,000 gallons of this super cold fuel that's chilled down to minus 423 degrees Fahrenheit. As you might imagine, at that temperature, there's a lot of thermodynamics at play. The transfer lines, the loading lines have to be all at the right temperature and pressure to safely flow this propellant, this fuel into the core stage. And that's those issues are concerns with the potential leak notwithstanding. So once they get back to the proper pressure and temperature, the flow will resume, and the team will monitor to see if there's still a sign of that leak in the tail service mast area. We received a little bit of a further update from NASA on the exact signature, data signature that the launch team saw a little while ago when they tried to transition the core stage load of liquid hydrogen from slow fill to fast fill. During that transition, launch controllers, according to NASA, saw a spike in the amount of hydrogen that is allowed to leak into the purge can, a housing covering the tail service mast umbilical's quick disconnect or mating interface with the rocket. This purge can housing again covers the interface between the tail service mast umbilical and the core stage, where the propellant loading line actually enters the rocket. NASA says that although a similar issue, as we mentioned earlier, a similar issue was identified in an earlier wet dress rehearsal, it may not necessarily be the same cause. This leak today may not be the same cause as the leak that was discovered in April. NASA has called this a potential leak, and we've said that there are signs of a leak, and in fact, one of the purposes of redoing this transition from slow fill to fast fill, resuming the flow, and going through that transition phase again, is to see if the data signature that they saw, the spike in the amount of hydrogen in that purge can area, happens again. So that would eliminate other potential causes of this signature, such as a sensor problem, and would help engineers determine if there is an actual leak in that area. It's a really nice view of the Space Launch System. At the bottom, those 4 RS-25 engines, the venting of vapors underneath that engine compartment. Now panning up the height of this launch vehicle, 322 feet tall, 98 meters in height. One of the largest launch vehicles ever built, and set to become the most powerful launch vehicle to ever lift off from U.S. soil at 8.8 million pounds of thrust. So NASA has reported that the slow fill of liquid hydrogen has resumed once more, and they hope to get to fast fill mode in a short while, and at that point the engineers will be looking for sensor data that shows the concentrations of hydrogen in the purge can area in the tail service mast umbilical. And the team will be watching to see if they see the same data signature they saw during that first transition to fast fill. That first transition to fast fill was nearly an hour ago. A little after 3 a.m. Eastern time is when we first heard the report that the hydrogen flow had stopped. So the team has been troubleshooting this issue now for a little more than 50 minutes. The countdown timeline is now at least an hour and 40 minutes behind schedule after a late start to propellant loading due to weather, some storms in the area here in the Kennedy Space Center, and now they've lost nearly an hour troubleshooting this potential liquid hydrogen leak out at the launch pad. NASA does have a 2-hour launch window available this morning. The window opens at 8:33 a.m. Eastern Time, 12:33 UTC, extends for 2 hours. Like I said, the launch window is determined by the performance of the Space Launch System, the position of the moon in its orbit, and a number of other factors. But this mission, this Artemis 1 test flight to carry the Orion capsule around the moon, has 2 hours to lift off this morning. The launch doesn't happen today. The next opportunity would be no earlier than September the 2nd. That is Friday. The launch window Friday would open at 12:48 p.m. Eastern Time, or 16:48 UTC. But NASA hasn't thrown in the towel yet for this morning's launch opportunity. And if this potential leak does scrub this morning's launch opportunity, it's not clear whether the issue could be resolved in time for a launch opportunity Friday. Back in April, when NASA and the Artemis launch team found a leak in the same area of the tail service mast umbilical, the repair had to be made back inside the vehicle assembly building. This graphic from NASA shows the current status of the propellant loading process. You can see the liquid oxygen tank on the core stage on the left side of your screen. 61% full, 119,000 gallons of the 196,000 gallon capacity of that tank has been loaded. On the right, the liquid hydrogen tank is shown at 12% full. About 65,000 gallons of 537 or 538,000 gallons approximately has been loaded. NASA says that the liquid hydrogen tank just transitioned to fast fill mode. This is the point at which the team detected a sign of a potential leak about an hour ago. So this is a critical point to see if that leak signature happens again here. Again, this is a point in the countdown that the launch team will be monitoring for any sign of a hydrogen leak in the purge can area of the tail service mast umbilical, which you see on the right side of the bottom of the core stage in this view. That's the structure that sticks above the mobile launch platform that connects up to the base of the core stage to load propellants into that rocket stage. Liquid hydrogen flow is now in fast fill. NASA confirmed a couple of minutes ago that that transition did occur. Now 17% full on liquid hydrogen, 63% full on core stage liquid oxygen. NASA's Artemis 1 countdown clock is now at T-minus 3 hours, 48 minutes, and counting. The liquid hydrogen flow continues at this time in fast fill mode. The launch team members over in the firing room at the Launch Control Center here at the Kennedy Space Center are closely watching this tanking process, focusing on a sensor reading in the tail service mast umbilical area near the bottom of the core stage of the Space Launch System. There's an area of that system called the purge can. It's an enclosure that closes around the connection between the tail service mast umbilical and the core stage itself. Those interfaces are where propellant lines that feed liquid hydrogen and liquid oxygen into the rocket connect to the vehicle during the tanking process. The hydrogen concentration in that purge can at last report from NASA was at 1.8% and did show some signs of climbing, but that's still below the 4% safety limit. So teams are closely watching this data as the liquid hydrogen loading continues. The liquid hydrogen tank is now 41% full on the core stage of the Space Launch System. And NASA reports that so far the hydrogen concentration levels in the purge can area of the tail service mast umbilical are holding under the 4% safety limit threshold. That 4% limit was tripped earlier in the countdown during the first attempt to transition to fast fill on the core stage hydrogen tank. But so far, the hydrogen tank this time has been in fast fill for some period of time without tripping that limit. So a promising sign now that the tank will be able to be fully loaded this morning. Now T-minus 3 hours and 27 minutes and 12 seconds. NASA a couple of minutes ago reported that the upper stage of the Space Launch System is now being loaded with its supply of hydrogen fuel. This liquid hydrogen will be loaded into the interim cryogenic propulsion stage. That will be followed a little later in the countdown by loading of liquid oxygen into the upper stage of the Space Launch System. So while core stage propellant loading continues, the upper stage is now beginning to be filled with propellants. NASA is continuing to hope to launch the Artemis 1 mission this morning during the 2-hour window, opening at 8:33 a.m. Eastern Time or 12:33 UTC. Just based on the timeline, it's going to be a challenge for NASA to launch this mission at the opening of the window, but there may be an opportunity to fit in a launch time later in the 2-hour window this morning. The other issue that may become a factor later on this morning will be the weather. There's an 80% chance of good weather at the opening of the window. However, toward the end of the window, there is a higher chance of rain showers that could be streaming onshore off the Atlantic Ocean. And one of the constraints for the launch of this Artemis 1 mission is flight through precipitation, which means there cannot be any rainfall on the pad or anywhere along the flight path of the rocket as it climbs through the atmosphere. Liquid hydrogen is now 56% full on the core stage. So the liquid hydrogen tank is now past the halfway mark on the Space Launch System's core stage. This is the largest propellant tank to be loaded this morning. It's a cool shot of the engine section at the bottom of the core stage. See some of the condensation, some of the water droplets dripping off of the core stage. Those 4 RS-25 engines there visible at the bottom of the field of view here, with their thermal insulation blankets surrounding the top of those nozzles where they connect up to the bottom of the core stage. Those thermal blankets are a little beefier, a little more resilient to heat than the thermal protection used on the engines in the Space Shuttle program. These engines are reused from the Space Shuttle program. During the shuttle launches, the engines were a little farther away from the nozzles of the solid rocket boosters. The engines are closer to that hot exhaust on the Space Launch System during the first 2 minutes of flight when those boosters are firing. So the engines will get hotter due to that proximity, requiring the addition of extra thermal protection to shield those engines from the hot gas from the plume of those solid rocket boosters. Now, T-minus 3 hours, 19 minutes, you can see the liquid hydrogen tank is at 64% full at this point. Liquid oxygen on the core stage now 81% full. You can see those temperatures there, minus 294 degrees for liquid oxygen, and liquid hydrogen even colder at minus 423 Fahrenheit. If you're just joining us, the Artemis 1 countdown is running a bit behind schedule this morning, but NASA is still hoping to launch this mission before the end of the window today. The window runs from 8:33 a.m. until 10:33 a.m. Eastern Daylight Time. That's 12:33 to 14:33 UTC. While we have your attention, I'll ask that you please like our stream if you haven't already. If you like our stream, that expands the reach of our coverage and helps us gain a bigger audience for this stream and others like it. Also, please consider becoming a member of our YouTube channel. We have different membership tiers available to you, and depending on which level you choose, you can gain access to exclusive video features, and you'll be supporting our coverage, helping us continue bringing you and the space community coverage like this of launch countdowns here at the Kennedy Space Center and at Cape Canaveral Space Force Station, and coverage of the wider space industry. You can also contribute through our Superchat function in the chat on the YouTube channel here. And you can subscribe. Please subscribe to our YouTube channel as well. That's free. And you'll get alerts of our coverage before our streams begin of launch activity, launch operations here in Florida. We want to thank Mary Davis for becoming a member a few minutes ago, joining us at the Pad Leader tier. Thank you, Mary Davis. T-minus 3 hours and 16 minutes and 13 seconds. You're looking at a view now from the top of the mobile launch tower, looking down on the 322-foot tall Space Launch System. Now just past T-minus 3 hours, 7 minutes, you're looking at a view of the Space Launch System core stage, part of the liquid oxygen feed line there, with some ice building up on that tube. Liquid oxygen is currently flowing into the core stage liquid oxygen tank through that feed line. The oxidizer enters the rocket through the tail service mast umbilical line connection, and then flows up that transfer feed line into the liquid oxygen tank on the core stage, which sits above the hydrogen tank on this rocket. This engineering camera now zooming in on one of the vents there near the bottom area of the liquid hydrogen tank, or the top of the engine section, right around that area. The liquid hydrogen tank is now 85% full. The loading has proceeded after it was stopped earlier in the morning due to signature of a potential leak in the tail service mast umbilical area. But after resuming the flow, into fast fill mode, the liquid hydrogen has loaded into the core stage at a good pace. Now 86% full. The liquid oxygen on the core stage now 89% full. The Artemis 1 countdown just passed T-minus 3 hours and counting. The countdown clock is heading toward a built-in hold at T-minus 10 minutes. There are 2 pre-planned holds in the Artemis countdown. One was at T-minus 6 hours and 40 minutes. We saw that hold begin late last night, and it was released this morning at 1:23 a.m. Eastern Time. And the next hold is expected at T-minus 10 minutes. That's a pre-planned hold that will last, or is scheduled to last, 30 minutes, although there is a chance that hold could be extended to make up for some lost time during this countdown. The countdown is running a little bit behind schedule this morning. That raises some doubt over whether the Space Launch System will be able to launch at the opening of today's launch window at 8:33 a.m. Eastern Time or 12:33 UTC, although NASA has not officially announced or set a new target launch time or T0 time for this morning. At this point, the liquid hydrogen tank on the core stage is at 97% full, so it's approaching the fully loaded status on the liquid hydrogen tank on the core stage. Liquid oxygen on the core stage now at 94%. We've just heard from NASA a couple of moments ago that the core stage liquid hydrogen tank is in topping mode. So that tank is being topped off at this point, nearing the 100% full level. This is the largest propellant tank on the Space Launch System moon rocket, 537,000 gallons. And that tank is now almost fully loaded. Liquid oxygen, meanwhile, on the core stage is at 97%. Here's the latest on the propellant loading status this morning. Both tanks on the core stage now around the 100% full level, and we just heard confirmation from NASA less than a minute ago that the liquid oxygen tank is now in topping mode. The liquid hydrogen tank was confirmed in topping a little more than 5 minutes ago. So final stages of propellant loading are being completed on the core stage, the most massive element of the Space Launch System, which comprises roughly 2/3 of the height of the entire rocket. 733,000 gallons of propellant has been loaded into the core stage. Still 22,000 gallons to be loaded onto the upper stage over the course of the coming minutes and hour or so. the Artemis 1 countdown just past T-minus 2 hours, 40 minutes, heading down toward the next hold, pre-planned hold at T-minus 10 minutes. With the core stage liquid hydrogen tank now topped off and in replenish mode, the launch team is given the go to start the core stage engine bleed kickstart. This is a procedure that will flow small amounts of liquid hydrogen into the engine compartment of the Space Launch System core stage to begin the process of thermally conditioning those engines for flight. This engine bleed kickstart procedure is associated with a quick disconnect that was found to be leaky during a wet dress rehearsal or practice countdown back on June the 20th. The launch team was able to proceed with that practice countdown despite this leak. They developed some procedures to mask the leak essentially from the computer system, the countdown sequencer, to allow the terminal countdown to proceed down to roughly T-minus 30 seconds during that practice countdown run. But that leak in the quick disconnect associated with the engine bleed for the Space Launch System core stage would have been a constraint to launch if that June 20th countdown had been a real countdown and not a rehearsal. NASA's ground processing team here at the Kennedy Space Center believes they successfully repaired that leak once the Space Launch System was returned to the vehicle assembly building. But that repair was performed at ambient temperatures, and leak checks were performed on that quick disconnect at ambient temperatures using helium. But hydrogen is a smaller molecule. It's also at cryogenic temperatures more than 400 degrees below zero. So the size and shape of this quick disconnect changes as it's subjected and exposed to cryogenic temperatures, and it makes it difficult for teams to say with certainty that they've fixed the leak until the same hardware is again put under cryogenic conditions. So we're about to see that in the next few minutes as this engine bleed kickstart procedure gets underway, and the launch team will get their first look at whether that repair is holding and whether the leak in that area has been resolved. This is a separate leak from the potential leak that we were talking about earlier in the countdown. It's in the same general vicinity near the tail service mast at the bottom of the core stage, but it's a different line. NASA's Artemis 1 countdown just passed T-minus 2 hours and 10 minutes. Now 2 hours, 9 minutes, 41 seconds and counting. The countdown is heading toward a built-in hold at T-minus 10 minutes. That's about 2 hours away from this point. That built-in hold is expected, was expected to last about 30 minutes, but it's likely to be extended. The latest report from Jeremy Graber, the Assistant Launch Director for Artemis 1, is that the team will reassess the timetable for when the Space Launch System might be ready for launch this morning. During that 10-minute hold at T-minus 10 minutes, there are 2 hours available for this morning's launch window, opening at 8:33 a.m. Eastern Time, or 12:33 UTC, closing at 10:33 a.m. Eastern, 14:33 UTC. The weather forecast continues to show an 80% chance of favorable weather at the opening of the window this morning. That probability of go or acceptable weather decreases to about 60% at the end of the 2-hour window due to the increasing threat of scattered showers as we get later into the morning here at the Kennedy Space Center. Right now, all weather parameters are observed green for launch. We had the chance to talk with Stu McClung, an engineer on the Orion team. He has worked on the Orion spacecraft for a great number of years, dating back to the early phases of that program's development. He's based at the Johnson Space Center in Houston. And here are his thoughts on the Orion spacecraft and the test flight that we'll be carrying out on Artemis 1.
Okay, I'm with Stu McClung, an engineer on the Orion program for NASA. Thanks for joining us, Stu.
Thanks for having me.
So this is a big test for the Orion spacecraft that's going to be taking it around the moon. But Orion has flown in space before, back on the exploration flight test. What is new on this particular mission, Artemis 1, that you were unable to test on EFT-1?
One of the most obvious things that folks will see, of course, this will happen on entry and landing day. And one of our key test objectives will be to demonstrate the heat shield performance at lunar reentry velocity. Right? So again, we had a heat shield on EFT-1. We got a good test of it. It was a slightly different config. It was what we call a monolithic heat shield. This one, as you should be familiar, has 186 blocks. Same material, but the block layout, and now we get to take that layout combined with the reentry velocity and validate that all of our ground-based testing that we've done in arc jets and other tests along the way is accurate, and we've got the proper margins built into it. And so that's one of the more obvious differences between EFT-1 and Artemis 1. And like you mentioned, we're off to the moon and lunar vicinity and out and beyond. And so with an extended duration, we'll have the opportunity to test my solar arrays and put them to really see how they perform, and as we do sun tracking. Every system we have the opportunity, we have well over 100 test objectives that we'll work through as the mission goes along, and to validate system performance as we go along the way. Inside the cabin, we've got some mannequins. It's an uncrewed mission, but I've got 2 mannequins that are set up in seats 3 and 4 that will be measuring the radiation environment that you see once you get outside the Van Allen radiation belts out in the lunar vicinity. Identical mannequins, but one's got a mask, or not a mask, one has a vest on it. They're both instrumented, and so we'll see how does that vest, what level of protection does it provide the future crews, and we'll feed that into future designs. We got a third, the Campos, or the moon, or the one that's sitting in the commander's seat, will be instrumented to measure ascent vibration, entry vibration, landing acceleration type loads.
And you mentioned the solar arrays. The service module is a new thing for Orion for this mission entirely, right?
Well, that's a great point, right? Yeah, we this really is the first full test of the service module. We partnered with the Europeans, basically leveraged the partnership that exists today on space station, and we've had really great success partnering up with our international partners. They came to us, joined us, all right? And so part of the service module is built by Lockheed, the external structure, the power plant, the solar arrays are provided by ESA and Airbus, that gets assembled in Bremen, shipped over here. So yeah, this will be something we couldn't do on EFT-1, where we'll test the entire propulsion system, the in-space propulsion system and power system for an extended mission.
I know after Artemis 1 comes back, there may be some lessons learned that you have to apply to the Artemis 2 vehicle that's being prepared right now here at Kennedy.
Right.
All things being equal, though, what are some of the planned differences and changes between the Artemis 1 configuration and the Artemis 2 configuration when you have crew?
So if we learn something significant enough that we need to modify it from Artemis 1, right, we would have that discussion and on-ramp that into Artemis 2 if it needs to be done, right? That would depend on what you might learn. Outside of that, we're bringing on the rest of the systems that are required for the crew, the rest of the ECLIS systems that are being tested in labs today, anything else. So the most obvious thing would be just the rest of the crew support systems. And on Artemis 2, we will fly a rendezvous, a portion of a rendezvous, to demonstrate our rendezvous capability ahead of when we rendezvous at the moon on Artemis 3.
In terms of the in-cabin atmosphere for this mission, you have the mannequins you mentioned. Would an astronaut be able to survive in that cabin on this particular mission, or are there still ECLIS functions missing?
There's ECLIS functions missing. We've got it pressurized. We'll maintain cabin pressure, but we're not maintaining cabin pressure with a standard breathable atmosphere. So we've got the proper pressure. We just don't have we don't have the need for the right mix. But yeah, so nobody on board this time around, and the mannequins won't complain about it.
If you could maybe point out some of the features on this model, like the different components, and what do you think is important to note?
All right, well, so Orion, and I always point this out to folks, right? Orion is the white section on top, right? So SLS is below me, right? So my SLS friends would call me a payload. In the launch abort system that you see here is not here in this model. Launch abort system sits on top of the vehicle. Then the crew module, service module below. The crew module is, I was going to pop it out, right? When we re-enter, the crew module is the only thing that comes back. The service module travels with the crew module for the entire duration of the mission until about 20-30 minutes before entering the Earth's atmosphere. Then we jettison it, separate, and it separates and then burns up in the atmosphere. Docking system is shown on top. On Artemis 1, there's no docking mission, but this model shows a docking mechanism that we'll have in future missions. See the umbilical here? This, again, the commodities, the power are carried down here in the service module, and there are a series of, if I remember right, about a dozen lines, combination of fluid and electrical lines that come up through this umbilical and then connect into the side of the crew module. And so, again, as we separate the crew module and service module, this is commanded to separate. There's some pyrotechnic bolts in there that push it away, and it hinges out of the way. You see the RCS thrusters around the side. When we're landing, when you open up and you're under 3 big main parachutes, and each main parachute's 116 feet in diameter. So at the end of the mission, when we're under our 3 mains, we are going to go where the wind takes us, clearly, right? You're going to go where the wind carries you. And but one of the things we do to make, and one of the things we'll test, is we steer the vehicle using these thrusters so that when the astronauts land, their legs, if you think about laying into a seat, they're going into the velocity vector, because the seats are designed to attenuate that landing load. And so we're giving them a straight-on entry versus a side hit. And so the thrusters, the propulsion system on the crew modules is important come landing day. To make sure that we give the crew a controlled re-entry and splashdown.
What's the expected splashdown velocity?
Splashdown velocity under 3 chutes is 25 feet per second, which is about 18 miles per hour. The rest of the vehicle designs assuming that we lost a main parachute. As you understand, right? We design to always survive those first failures, put fault tolerance and redundancy into the vehicle. So if we're under 2 mains, it's 33 feet per second instead of 25. But the structure and everything else is designed assuming that happens. And so when we give them 3 good mains, right, they're well within guidance.
And I think you pointed out the launch abort system. This particular mission does not have a launch abort motor, if I understand correctly.
That's correct.
Obviously, you don't have crew on board, but why not have the full configuration?
It was a trade, since we had done pad abort 1 test of the launch abort system, and then the ascent abort test that we did here at the Cape 3 years ago. Don't need to test it, and so basically it was a cost savings trade. So we're not going to abort. It does have the jettison motor, so once we get up in the right stage of ascent, it will jettison and fly away. So we just made that trade. The Artemis II one clearly will be fully outfitted, but we were able to test the launch abort system independently to the point that we don't need to rely on Artemis I as a test event for the abort motor.
Okay, Stu, thanks for joining us. Good luck with the mission.
Thank you. Looking forward to it.
That was Stu McClung, an engineer on the Orion program, working on the Orion spacecraft. He's based at the Johnson Space Center in Houston, and here's a look at the Orion spacecraft mounted on top of the Space Launch System out on Launch Complex 39B this morning. The core stage remains fully loaded with propellants at this time. Liquid hydrogen loading on the second stage is underway. We've got an update from NASA on the status of that engine bleed kickstart procedure that I talked about a few minutes ago. This is the procedure that flows small amounts of liquid hydrogen from the core stage into the engine compartment to begin conditioning the 4 RS-25 engines at the bottom of the core stage. NASA reports that the engine bleed for 3 of the 4 engines appears to be working normally, but they're not seeing the bleed they want to see for engine number 3 on the core stage. So the launch team is currently troubleshooting that issue. One of the next steps in this bleed configuration is to set up for what they call a pre-press test. This is when the launch team will close vent valves on the core stage, build up some pressure in the tanks, and then that will help the team confirm that there's no leak path in any of that bleed system. There was a leak discovered in one of the quick disconnects in the engine bleed line back in June on a countdown rehearsal. NASA technicians believe they repaired that quick disconnect leak in the vehicle assembly building when the Space Launch System was rolled back to the hangar following that June 20th countdown rehearsal. And then, of course, the rocket was returned to Pad 39B a couple of weeks ago in preparation for this morning's launch attempt. The countdown clock here at NASA's Kennedy Space Center just past T-minus 1 minute, or 1 hour, 56 minutes. Heading down toward that next built-in hold at T-minus 10 minutes. And we expect to hear, assuming the countdown proceeds down to that point, we expect NASA's launch team to set a new target launch time sometime during that 10-minute hold. And then we'll learn when NASA hopes to target the launch of the Space Launch System this morning, the first flight of this Artemis I moon rocket. In this view, you can see the vehicle out on Pad 39B, lit up by spotlights this morning. To the right, you can see the flame stack at Launch Complex 39B. This stack burns off any excess hydrogen gas that may be in the, or hydrogen rather, that may be building up in the atmosphere. It helps to burn off any hydrogen that could cause a flammability or explosion risk out at the pad. And that flame stack becomes more active once hydrogen begins loading into the launch vehicle. NASA reports that the launch team is now assessing what appears to possibly be a crack in the intertank flange area on the core stage. There's some frost building up in that apparent crack, and engineers are now discussing whether that might be a concern for the remainder of the countdown and the launch this morning. Not yet clear how serious this issue might be. And another update from Artemis Launch Control. NASA says the liquid hydrogen team is continuing to try to get a good bleed flow to engine number 3 at the bottom of the core stage of the Artemis 1 moon rocket. After adding some pressure to the core stage tanks, the team still wasn't able to get the bleed flow they wanted leading into engine number 3. The other 3 engines have a good bleed to begin their thermal conditioning process before ignition. So right now the team is discussing or planning to pressurize the core stage up to flight level to try to add even more pressure into that system to try to force through that bleed flow of liquid hydrogen to begin thermally conditioning engine number 3. Again, the other 3 engines do have a good bleed flow, according to NASA. You can see here this zoomed in view without zooming out, some great detail on the Space Launch System core stage, looking in the general vicinity of the engine section. There is one of the attachment struts connecting the solid rocket booster, one of the solid rocket boosters, to the core stage. The launch team is continuing their video survey using these remotely operated engineering cameras out mounted on the mobile launch platform and the mobile launcher tower at Launch Complex 39B. T-minus 1 hour, 33 minutes, 19 seconds, and counting. There are still a couple of issues that are being worked by the Artemis 1 launch team right now. One of them involves the engine, the bleed flow to engine number 3 on the core stage. This is a hydrogen bleed that is necessary to thermally condition the 4 RS-25 engines for engine start, which occurs at about T-minus 6 seconds in the countdown. 3 of the 4 engines have a good bleed flow according to NASA's Artemis Launch Control Team, but engine number 3 still is not within the correct parameters, the right temperature that they're looking for getting within the parameter space, proper conditions for engine start. So the team believes there's not enough pressure in that bleed flow leading to engine number 3, and there are several different troubleshooting actions that the team has conducted or is conducting to try to get that pressure up to restore that bleed flow to sufficient levels to get that engine within the proper thermal bounds for ignition. Now 2 hours remaining until the start of today's Artemis 1 launch window, which itself runs 2 hours. So actually it's 2 hours away from the opening of the window now, 4 hours away from the closing of today's Artemis 1 launch window. Here's a gorgeous view from the Kennedy Space Center press site this morning. You can see the crowds of news media gathered here, roughly less than 4 miles away from Pad 39B, where the Space Launch System moon rocket is awaiting a possible launch opportunity this morning to carry NASA's Orion spacecraft out to the moon on a 42-day test flight. This is the first launch of NASA's Artemis program, the first flight of the Space Launch System, which, when it takes off, will become the most powerful rocket to ever have launched from U.S. soil. A beautiful dawn here on Florida's Space Coast. You see the countdown clock on the right, T-minus 1 hour, 24 minutes, 30 seconds. The countdown is heading toward a built-in hold at T-minus 10 minutes. And at that time, we expect that hold to be extended beyond the planned 30-minute duration to target a launch time sometime within the 2-hour window this morning, which opens at 8:33 a.m. Eastern or 12:33 UTC. We don't expect the launch to occur at the opening of the window. We expect NASA to target sometime later in the window, and that assumes that these open, unresolved issues, such as the potential crack or at least a line of frost or ice buildup on the intertank area of the core stage that NASA is studying, as well as the bleed flow to engine number 3. Those issues still need to be addressed before this mission can get off the ground this morning. We're watching gorgeous views here from the Kennedy Space Center as the sun light begins to creep above the eastern horizon out over the Atlantic Ocean. The flame stack to the right of Pad 39B flaring up, burning off hydrogen. You can see the crowds gathered here on the lawn of the Kennedy Space Center press site. The latest report on the status of that engine bleed issue on engine number 3 of the core stage is that the launch team has cycled a bleed valve associated with that several times, multiple times at least. and that has not yet resolved that concern, that issue with the bleed flow into engine number 3. Really is a gorgeous morning here at the Kennedy Space Center. If you're just joining us, we've been covering the Artemis 1 countdown throughout the night. It's been a bit of a roller coaster journey with stops and starts of a liquid hydrogen flow on the core stage after the detection of an apparent leak in the tail service mast umbilical. That's the connection between the mobile launch platform and the core stage through which propellants flow into the rocket. But after some troubleshooting, the launch team got that leak down to safe, manageable levels and within limits. That allowed the team to proceed through loading the entire tank of liquid hydrogen. 537,000 gallons were loaded into the core stage. In parallel with that activity, liquid oxygen also flowed into the core stage. So the core stage right now is full of 733,000 gallons of cryogenic propellants. Loading of propellants into the upper stage has also gotten underway. We haven't heard any exact status report of where exactly that stands right now in some period of time, but we're not aware of any issues with loading the upper stage of the Space Launch System moon rocket. So after clearing the hurdle with the potential hydrogen leak in the tail service mast umbilical area on the launch platform, we did hear reports from the Artemis launch team that the bleed flow into engine number 3, this is a flow of liquid hydrogen to thermally condition the engines for ignition. That bleed flow was not satisfactory, was not meeting expectations. The other 3 engines do have a good engine bleed kickstart to begin that thermal conditioning process. And so far, the troubleshooting efforts to try to recover that bleed flow into engine 3 have not been successful. But NASA engineers are continuing to evaluate their options on how they might be able to recover that. and still proceed with the launch this morning. Early on in the countdown, overnight or late last night, the loading of cryogenic propellants also got a late start due to some stormy weather that was approaching the Kennedy Space Center area with the threat of lightning. So the propellant loading started nearly an hour behind schedule and then fell further behind with that troubleshooting of that liquid hydrogen leak in the tail service mast umbilical area. And now the team is working another issue with the engine bleed to engine number 3 on the core stage. There's also been discussion of a line of ice or frost that may be indicative of a possible crack in the thermal protection system or foam insulation on a portion of the core stage. We're not really sure how serious that issue might be, if that's a real issue or whether that's just something the team is trying to look at to make sure it's not an issue or not a concern for the countdown this morning. So we'll wait on the word from Artemis Launch Control on those discussions. NASA has said that there's a lot of expectation among the launch team members that the launch time, assuming these issues are cleared, will have to be delayed into the launch window this morning. So it's unlikely that the launch will happen at 8:33 a.m. Eastern Time. There is a 2-hour window to get this Artemis 1 lunar test flight off the pad here at the Kennedy Space Center. That window closes today at 10:33 a.m. Eastern Time or 14:33 UTC. Later on in the window this morning, there is an increasing threat of rain showers that could violate the flight through precipitation rule. The launch pad and the flight path of the Orion spacecraft and the Space Launch System have to be clear of any precipitation to allow this launch to proceed. Going into this countdown, the weather team expected the conditions at the opening of the window to be better than at the end of the window. NASA does have backup opportunities available to launch this mission if the launch can't get off the ground this morning. The next opportunity would be Friday, no earlier than Friday, September the 2nd. Now, T-minus 1 hour, 10 minutes, and counting. We're about an hour away from the built-in hold at T-minus 10 minutes. That's when the countdown clock will be stopped. This is a pre-planned hold in the Artemis 1 countdown. The latest update from NASA's Artemis Launch Control Center here at the Kennedy Space Center is that the launch director, Charlie Blackwell Thompson, has approved a new troubleshooting step to try to recover this engine bleed to engine number 3 to get that engine down to the proper thermal conditions, proper temperature for flight. The engine bleeds to engines 1, 2, and 4 has been those bleed flows of liquid hydrogen into those engines have been working, and the next plan will be to close valves leading into those engines to eliminate those bleeds and to force the bleed pressure from the tanks or the tank of the core stage down into engine 3 to try to ramp up that pressure to get liquid hydrogen flowing down into that engine to get it to the proper temperature and to go condition for flight today. This is a cool view from Launch Complex 39B, looking at one of the umbilical arms. This is one of the arms that will swing away from the rocket at launch time. One of the nose cones to one of the solid rocket boosters is also visible with that black band just under the nose cone. One of the boosters has that black band to distinguish it from the other booster. In the background to the right is the vehicle assembly building, some 4 miles away. This view of the Space Launch System on pad 39B comes from a camera on the roof of the vehicle assembly building. We saw the VAB a few moments ago from the vantage point of pad 39B. Now you're seeing pad 39B from the VAB. In the background, there's a security vessel, likely a Coast Guard vessel, just offshore in the Atlantic Ocean. These vessels are periodically visible just off the coast during launch countdowns to clear the maritime exclusion zones, make sure there's no ships or any other traffic in the area under the flight path of the rocket. T-minus 1 hour, 3 minutes, 30 seconds, and counting. This view from a camera on board one of the lightning towers out at pad 39B shows a great shot of the Atlantic coastline. I want to draw your attention to the right of the frame. You can see SpaceX's Launch Complex 39A there in the background. The rising Starship launch tower visible there at pad 39A, as well as the fixed service structure that supports crew launches on the Falcon 9 rocket that SpaceX uses to send astronauts to the International Space Station. Farther in the background, you can see United Launch Alliance's Launch Complex 41 area for the Atlas V rocket, also home to a crew access tower for future crew flights on the Atlas V and Boeing's Starliner spacecraft. So here in this one frame, you can see the 3 human-rated launch pads at the Kennedy Space Center and at Cape Canaveral Space Force Station. In the foreground, obviously, the Space Launch System for the Artemis program to carry astronauts back to the moon. Beyond that, pad 39A for astronaut flights to the space station. And in the distance, pad 41, ULA's Atlas V launch complex that is ready from a ground systems perspective to support crew launches on the Starliner spacecraft built by Boeing. In the lower, here's a view of pad 39A from the press site here from a camera we have looking out toward the east toward launch pad 39A. You can see that Starship tower. 7 of 9 segments have been raised and lifted onto that tower. Also, the water tower that's going to be used to support Starship launches from pad 39A is also taking shape. And on the left is the Falcon 9 launch mount and the transporter erector arm for Falcon 9 rockets sitting horizontal down on the top of the pad, ready to roll back into the hangar sometime in the coming days to pick up another Falcon 9 rocket for the next flight from this pad. On the lower left of this view, you can see one of the transfer lines, one of the cryogenic propellant transfer lines, those vapors venting away from that cross-country line leading to one of the cryogenic storage spheres out at pad 39B. So earlier in the countdown when we were talking about chilling down the transfer lines, that's one of those lines that flows propellants from the ground storage facility into the rocket. just past the T-minus 59-minute point in the Artemis 1 countdown. No further update in the last couple of minutes on the technical issues being worked, namely the bleed flow to engine number 3 on the core stage, and this line of frost or ice and a potential crack in the intertank area of the core stage. We haven't heard anything about that issue in some time, actually. Most of the chatter from the NASA launch commentator of late has been focused on this engine bleed issue. Typically at this point in the countdown, we'd be hearing chatter from the launch control team members themselves as they work through issues like this. But NASA is not releasing any of the countdown audio nets until the point about 15 minutes before liftoff. At that point, we will get some audio feeds from the Launch Control Center. We can listen in to the launch director poll at that point. But we're not hearing any of the discussions on the countdown loops as the team works through these issues and has worked through the tanking of the Space Launch System moon rocket. NASA has cited export control restrictions for not releasing this audio to the media and to the public. So if you're wondering why you're not hearing audio from launch control, from the launch director and the other members of the launch team, that's the reason, according to NASA, is they're not releasing any of that audio until the launch minus 15-minute point. 15 minutes before launch is when we'll begin hearing that audio. Other companies, other launch providers such as the United Launch Alliance and SpaceX do release some countdown audio during the fueling process of their rockets to the news media to allow for coverage of their launches, but not the case for the Space Launch System, at least for this first test flight on Artemis 1. We're not going to hear that until the final 15 minutes of the countdown. We're also not seeing any video of the launch team inside the firing room as they work through these issues. In the past, it's been customary for NASA launches dating back to the shuttle program to have camera views inside the firing room to show the launch team members in a wide view as they work through the countdown, but we're not seeing that this morning either. Just a minute or so ago, we did hear another update from the NASA launch commentator that the launch director has asked the team to come up with next steps to determine what to do next in this countdown. Again, there's the open, unresolved issue involving the bleed flow to engine number 3 on the core stage. That engine has not been able to get down to the proper operating temperature for engine ignition and launch. The flows to the other 3 engines have been working properly, according to NASA. And there was discussion a little bit earlier this morning about possible crack in the intertank area of the core stage. We haven't heard much about that in the last few minutes, but we'll stand by for news there. Also, there's the lingering issue that was an issue from the very start of the countdown, or the very start of cryogenic tanking operations, which involves a communications issue with the Orion spacecraft. We haven't heard anything about that in some time, as events may have overtaken that with all these discussions about leaks and the bleed flow on engine number 3. So we'll stand by for word from NASA on whether that Orion communications concern has been fixed or resolved. It's a good view of the RS-25 engines, four of those engines mounted on the bottom of the core stage. And the liquid hydrogen bleed flow into one of those engines is the main concern under discussion by the Artemis launch team right now. The liquid hydrogen team in the Launch Control Center is continuing to discuss options to continue troubleshooting this bleed flow into engine 3 that's not providing the engine with the proper thermal conditions for flight today. This bleed involves flowing a little bit of liquid hydrogen into the engine plumbing to get those engines chilled in for engine start. They need to be within the proper temperature bounds. There's a lower and upper limit for that. And engine number 3 is not currently able to reach within those temperature bounds due to an issue with this bleed flow. Here's a view of the Space Launch System out at Pad 39B. We've passed sunrise here on the Florida Space Coast. On the lower right, you can notice some vapors around the transfer line for liquid hydrogen that flows up the incline to the top of the launch mount from a storage sphere on the northeastern perimeter of Pad 39B. The liquid hydrogen tank for the core stage is currently in replenish mode. So there continues to be a little bit of liquid hydrogen flowing through that transfer line into the core stage to gradually replace the liquid hydrogen that bulls off into a gas to make sure that the core stage tank remains at flight level. Same thing going on with liquid oxygen. The liquid oxygen tank is in the distance. You actually can see that liquid oxygen sphere in the distance on the lower right of this screen on the northwestern side of the pad. Here's a view from one of the engineering cameras at Pad 39B showing the 4 RS-25 engines on the bottom of the core stage. Engine number 3 is the one that's experiencing this problem with the bleed flow of liquid hydrogen. And just getting our geometry right, we believe that engine number 3 is on the lower left in the foreground here. The engine that's most prominent in this field of view, we believe, is engine number 3. Each of these engines can produce about 500,000 pounds of thrust in the vacuum of space, roughly 400,000 pounds at sea level. And they consume liquid hydrogen fuel and liquid oxygen as oxidizer. NASA says that there will be an unplanned hold inserted into the countdown at T-minus 40 minutes to allow the liquid hydrogen team to continue their troubleshooting. We expect to see the clock here stop momentarily. T-minus 40 minutes and holding. The countdown clock has stopped at 40 minutes. This is an unplanned hold in the Artemis 1 countdown. This is not yet an indication or confirmation that NASA has scrubbed or thrown in the towel for this morning's launch opportunity, this morning's launch attempt. There is still some troubleshooting plans being developed by the launch team to try to restore this bleed flow to engine number 3 to get that engine down to the proper operating temperature for launch. The liquid hydrogen team will take a few minutes here to develop that plan and present that plan to the launch director, Charlie Blackwell Thompson, and then she will consider that and decide whether to implement those troubleshooting steps. The countdown had been ticking down toward a planned built-in hold at T-minus 10 minutes. There still will be a hold at T-minus 10 minutes if this countdown clock is able to resume. There still will need to be a hold at 10 minutes to allow for the polling of the launch team for a go or no-go to enter into the terminal countdown sequence, which begins at T-minus 10 minutes. And when the countdown picks up at 10 minutes, that's when the ground launch sequencer computer takes automated control of the countdown. You can see here this view from the west looking to the east, sunrise out over the Atlantic Ocean here on Florida Space Coast this morning. And we'll stand by for further news from NASA and the Artemis control team on exactly what these next steps might be to try to restore this bleed flow to engine number 3, which appears to be a constraint for launch this morning if it's not resolved. Latest update from Artemis Launch Control is that one of those issues that we were discussing that involved the potential crack in the intertank area of the core stage, that concern has now been cleared. Engineers have determined that some frost and ice has built up in a crack in the foam, but there's the conclusion is that that crack is not an issue on the structure of the core stage itself. And NASA's launch commentator says that this is a phenomenon known as cryopumping that was observed back in the days of the space shuttle program with the foam on the external tank used on the space shuttle. And this similar issue has been observed this morning on the Artemis 1 core stage. So that concern has been resolved, no longer an issue for the countdown, which continues to hold now at T-minus 40 minutes. This is an unplanned hold to allow the liquid hydrogen team over in the Launch Control Center to come up with additional troubleshooting plans to try to recover this hydrogen bleed flow into engine number 3 that is providing insufficient cooling for that engine. That engine has not been able to reach its proper initial temperature. It needs to reach a certain temperature threshold before engine start. That's enabled by this bleed flow. The other 3 engines were able to reach that threshold, but engine number 3 has not reached that threshold despite several valve cycles, including pressurization tests of the core stage to try to drive pressure through that bleed line into engine number 3. That did not work. And now the team is assessing next steps and further options that they may be able to implement to try again to try to recover that bleed flow and get engine 3 back to its proper temperature for engine start. Here's a live shot from a camera view on top of the vehicle assembly building looking down toward the launch and landing facility. This is Air Force Two carrying Vice President Kamala Harris arriving for today's launch opportunity, today's launch attempt for the Space Launch System and the Artemis 1 mission. Vice President Harris is expected to tour the Kennedy Space Center, visit facilities where the hardware for the Artemis 2 and Artemis 3 flight elements are being prepared for flight. The crew modules for the Artemis 2 and Artemis 3 Orion spacecraft are currently here at the Kennedy Space Center. So Vice President Harris will take a look at those, and she's expected to give a speech around noon Eastern Time. And she's arriving for an opportunity to view the Artemis 1 launch this morning. If the launch does go ahead, the countdown is currently in a hold at T-minus 40 minutes as the launch team works an issue involving the bleed flow into engine number 3 at the bottom of the core stage. This bleed is not providing enough cooling to engine number 3 to get it down to the proper temperature for ignition. So we're standing by for an update from the launch team as they discuss what their next steps are this morning. The countdown has been in this unplanned hold at T-minus 40 minutes now for more than 35 minutes. At the time of the hold, when this hold was begun, the NASA launch commentator said the hold was expected to last around 10 minutes to give the team time to develop a troubleshooting plan to present that to the launch director, Charlie Blackwell Thompson, and then get her sign off on that plan. But the hold has run longer than anticipated. The launch window this morning actually opens in 28 minutes. That's the opening of the 2-hour window for the Artemis 1 launch opportunity today. Runs until 10:33 a.m. Eastern Time. as the Space Launch System countdown remains in this hold at T-minus 40 minutes. There are some rain showers approaching the Kennedy Space Center and the Cape Canaveral Space Force Station area from the south. Those showers are moving north, and if they don't dissipate, they're expected to move over the Kennedy Space Center area and the launch pad in a short time. We're still waiting on an update from the Artemis 1 launch team on what their next steps might be this morning, as the countdown has been held up by this issue with the engine bleed flow into engine number 3. Engine number 3 is one of the 4 RS-25 engines that power the core stage of the Space Launch System. These engines are manufactured by Aerojet Rocketdyne. They're actually leftover engines from the Space Shuttle program. They consume liquid hydrogen and liquid oxygen propellants and produce more than 400,000 pounds of thrust each at sea level. And part of the countdown procedure leading up to liftoff to ready these engines for ignition is to actually chill down these engines, get them down to very cold operating temperatures before the flow of cryogenics into the engines at engine start. And this bleed flow involves flowing a little bit of liquid hydrogen into the engine compartment through some of the plumbing in the engines to condition these power plants for engine startup sequence. And we've heard from NASA that engines 1, 2, and 4 had a good bleed flow and reached their proper thermal conditions for ignition, but those conditions were not reached with engine number 3. And the launch team tried several troubleshooting actions to try to regain that flow into engine 3. Those involved valve cycling attempts, as well as pressurization of the tanks, or the liquid hydrogen tank on the core stage, to try to force some of that hydrogen through the bleed line into engine 3. And then the most recent troubleshooting attempt that we've heard about was the closure of valves, the bleed valves on engines 1, 2, and 4, to try to force all of that bleed system pressure into engine 3. None of those troubleshooting attempts worked, and engine 3 still has not reached its operating thermal condition, the proper operating thermal conditions for engine start. This hold has now been running for about 45 minutes. If you're just joining us, I'm Stephen Clark, editor of spaceflightnow.com. We're reporting live on the status of the countdown of the Artemis 1 mission here at the Kennedy Space Center in Florida. The countdown is in an unplanned hold at this point as the team troubleshoots an issue with one of the engines on the core stage of the Space Launch System. While we wait for a word on the next steps, we invite you to please like our stream if you haven't done that already. You can also join our YouTube channel. We have various membership tiers available for you to choose from. Depending on which level you choose, you can gain access to exclusive video features from our work here at Cape Canaveral covering launch operations. We cover all launches here from Florida Space Coast. Of course, this Artemis 1 mission is one of the biggest in recent memory. You can also contribute and help support our coverage through the Superchat function here on our YouTube channel. And if you haven't already, please subscribe to our channel so you can get notice of our broadcasts before we go live before each launch. You can also go to our Spaceflight Now store. Go to shop.spaceflightnow.com. We have a number of patches and other items and memorabilia there for purchase. Notably, related to this mission, on the left we have the Artemis program patch available for sale, as well as the Artemis 1 mission patch. And then at lower left we have a special commemorative Artemis patch available. These are all available in the Spaceflight Now store at shop.spaceflightnow.com. We mentioned a few minutes ago that there was a band of thunderstorms and rain showers approaching the Kennedy Space Center area, and this may not be an issue given that NASA is working this problem with the engine bleed valve, but the cumulus cloud rule has just toggled red, so the cumulus cloud rule is now red here at the Kennedy Space Center. The latest update from NASA's Artemis Launch Control Center is that the Launch Director Charlie Blackwell Thompson continues to discuss options with the cryogenics team on a path forward this morning. Still no word on how the team intends to proceed with this countdown. The Artemis 1 countdown continues holding at T-minus 40 minutes. NASA has provided another update on the status of this morning's countdown operation. NASA says teams are in a hold in the countdown at T-minus 40 minutes, while engineers continue to assess and issue conditioning engine 3, one of the 4 RS-25 engines on the bottom of the Space Launch System rocket's core stage. NASA says engineers are looking at options to gather as much data as possible, and that could suggest that the team is trying to gather information that could help them develop a plan to ultimately resolve and repair this issue after today's launch attempt. The launch window opens in 3.5 minutes and closes in 2 hours. And just based on the nominal timeline, just looking at the clock, not considering the time it may take to condition the engine number 3 on the core stage if the bleed was restored at this moment. Just looking at the countdown clock, there's about 80 minutes from right now until the earliest possible launch opportunity. But there are other factors at work, including the time needed to troubleshoot and restore this bleed flow, if it's at all possible, if it's even possible today, and then get the engine down to the proper conditions, proper thermal conditions. So with this engine bleed issue still unresolved, the odds of a launch this morning appear to be declining here at the Kennedy Space Center, but still no official word on a scrub from the launch team or the launch director at this time. The countdown has been in this unplanned hold at T-minus 4 minutes for about 1 hour and 4 minutes or so, maybe 1 hour and 5 minutes at this time. At the time of the beginning of the hold, NASA's launch commentator said the team expected the hold to last just about 10 minutes, so we're well beyond that. And again, the weather conditions are expected to become less favorable over the next few minutes, with a rain shower about to move over the Kennedy Space Center. And it looks like it's on a path to also move over the Launch Pad 39B area. But the weather is a secondary factor right now. The main concern is the engine bleed on engine number 3 of the core stage. And we've now hit the opening of this morning's Artemis 1 launch window. It's 8:33 a.m. Eastern Time. It's now 12:33 UTC. So this was the opening of this morning's 2-hour launch window here at the Kennedy Space Center for Artemis 1. But liftoff is not happening at the opening of the window, and odds of it happening before the end of the window aren't looking particularly favorable at this time. NASA Launch Director Charlie Blackwell Thompson has just announced and confirmed a scrub. So the Artemis 1 mission will not be launching this morning. The next available launch opportunity, assuming this engine bleed issue that caused the scrub can be resolved, would be no earlier than Friday. NASA's launch commentator has now signed off, and we're not expecting to hear any more real-time updates from the Launch Control Center, but if you're just joining us, the launch was scrubbed by Launch Director Charlie Blackwell Thompson a couple of minutes ago due to this issue with the engine bleed on engine number 3 of the core stage of the Space Launch System moon rocket. Engineers have spent the last couple of hours evaluating this issue, and despite multiple different types of troubleshooting attempts, they were not able to get this flow going enough to cool down and thermally condition engine number 3, and it has to be at a certain temperature threshold. Engines 1, 2, and 4 met that threshold, but engine number 3 did not reach that thermal threshold. So the next steps will be to back out of the launch countdown and drain the Artemis 1 rocket of its cryogenic propellants. The team had the rocket nearly fully loaded, not quite 100% full on all of its tanks. The core stage was fully loaded. The upper stage did not quite reach the full point, not quite the 100% levels on the upper stage. So those propellants will be drained over the coming hours. That's a multi-hour process to drain those propellants, just as it was a multi-hour process to load them. The next launch opportunity would be no earlier than Friday at 12:48 p.m. Eastern Time. That is the opening of a 2-hour window, so 12:48 p.m. to 2:48 p.m. Eastern, 16:48 to 18:48 UTC. But that launch opportunity Friday hinges on the successful resolution of this engine bleed issue, which is a constraint to launch. You're looking now at the engine bay on the core stage, the 4 RS-25 engines visible there. If we have our bearings right from where this camera is located, we believe engine number 3 is the engine in the foreground, the most visible engine on the lower left of this view. is engine number 3. This wider view of the Artemis 1 vehicle, this looks from a camera on one of the lightning protection towers, looking toward the southeast, out over the Atlantic Ocean. You can see that rain shower that we discussed a few minutes ago is approaching the Kennedy Space Center area. It's currently already raining over Cape Canaveral Space Force Station next door. To the right, on the right edge of the screen, you can see SpaceX's Launch Complex 39A. So just to recap what happened with this countdown, the loading of cryogenic propellants began nearly an hour late due to a thunderstorms that brought the threat of lightning inside the 5-mile ring around the launch pad. That's a constraint for propellant loading. That lightning cleared, allowing the cryogenic tanking operation to get underway. There was a detection, a signature of a hydrogen leak in the tail service mast umbilical that connects the mobile launch platform with the bottom of the core stage. That leak was detected when the core stage liquid hydrogen loading transitioned from slow fill to fast fill. And after some troubleshooting steps, including the restart of, first of all, the termination of flow of liquid hydrogen, then the restart of flow into the core stage at slow fill mode, and then back into fast fill, it appeared like that leak level decreased back to within acceptable limits, and that allowed the core stage to be fully loaded with liquid hydrogen and liquid oxygen. So NASA got a full load of propellants on the core stage during this countdown, a little later than expected, behind schedule, but a full load of propellants on the core stage. And then the next step was to begin this bleed into the engine section, to begin chilling those engines down for ignition. This bleed system also caused trouble back on a wet dress rehearsal, practice countdown on June the 20th. The launch team detected a leak in a 4-inch quick disconnect connector that flows hydrogen into that engine bay, into that engine compartment for chill down. NASA's launch team continued the practice countdown despite that leak. They masked that leak. It was not a constraint to continuing that countdown rehearsal. It would have been for a launch, but they were able to continue down to T-minus 30 seconds, gathering a lot of data and practice run through the countdown for the launch team. And then at that point, NASA rolled the Artemis 1 rocket back into the vehicle assembly building for final closeouts and outfitting for launch, and a repair to that hydrogen leak in the bleed system and that quick disconnect fitting, and then return the rocket to the pad earlier this month for today's launch opportunity for the Artemis 1 test flight to the moon. So that leak that was found back on June the 20th prevented the bleed flow from getting underway into the engines, and prevented NASA and the launch team from testing that bleed function. That was one of the items, one of the boxes left unchecked from that wet dress rehearsal. And it appears, at least right now, that may be related to the issue that caused the scrub today. We'll wait for further details from the NASA launch team. We hope to hear from them in a press briefing, potentially. We haven't heard official schedule for a press briefing yet from NASA to gather more details on exactly what happened. Now, a little more than 20 minutes since Launch Director Charlie Blackwell Thompson declared a scrub for today's Artemis 1 launch attempt. You're continuing to watch live views from Launch Complex 39B. This is a view from the top of the mobile launch tower looking down on the Space Launch System, which stands 322 feet or 98 meters in height. With this countdown, this launch attempt now scrubbed, the next step will be the safing and securing of the Space Launch System, as well as the draining of cryogenic propellants from the rocket. As you can see, that rain shower we saw approaching a few minutes ago has now arrived at pad 39B. Some rain is now falling out at the launch pad. And we'll still await further word later today or in the coming days on when NASA might be ready to make another run at launching this Artemis 1 mission to the moon. Hello again from NASA's Kennedy Space Center in Florida. You're looking at live at Launch Complex 39B at the Orion spacecraft, sitting on top of the Space Launch System moon rocket following today's scrubbed countdown. NASA Launch Director Charlie Blackwell Thompson declared a scrub at around 8:35 a.m. Eastern Time, about 35 minutes ago. Due to this issue with the engine bleed flow leading into engine number 3 on the bottom of the core stage. This is one of the 4 RS-25 engines on the bottom of the core stage of the Space Launch System. And here's a view up close of that engine bay at the bottom of the core stage. You can see these 4 RS-25 engines. These are leftover engines from the Space Shuttle program. All have flown on the Space Shuttle before. And we believe, if we have our bearings right on where this camera is, engine number 3 is the one on the lower left in the foreground. You can see these engines are wrapped in thermal insulation, a heat shield, a heat barrier, where they connect into the core stage engine section. The bleed flow is designed to feed a little bit of liquid hydrogen into the engines to begin conditioning them. This is a procedure that's known in the rocket business as chill down. The engines have to be at a certain thermal threshold, temperature threshold, to be ready for ignition and ready for flight. 3 of the 4 engines reached that threshold with their bleed flows this morning, but engine number 3 did not. The launch team performed multiple troubleshooting steps, cycling valves, increasing pressure in the liquid hydrogen tank to try to force that fluid, that propellant, through the bleed line into the engine. None of those activities got the result that the launch team wanted, though, and ultimately the launch director declared a scrub. It's not officially known yet when the next launch opportunity might be for the Artemis 1 mission. Just based on orbital dynamics alone, the next opportunity to launch the mission would be no earlier than Friday. There's a 2-hour launch window available Friday, 12:48 p.m. to 2:48 p.m. Eastern Time, 16:48 to 18:48 UTC. But that will hinge, obviously, on the resolution of this engine bleed issue, which is a constraint to launch. NASA has launch opportunities beginning Friday, September 2nd, as well as September 3rd, 4th, 5th, and 6th to begin the Artemis 1 mission to the moon. If the launch isn't off by September the 6th, the next launch period opens on September the 19th. But there are other constraints and factors that the team will have to consider. One of those, obviously, is if the repair to this engine bleed requires access to certain parts of the vehicle or the ground support system, the tail service mast umbilical, for example, the rocket could have to be rolled back to the VAB, to the vehicle assembly building, for that repair work. And that repair notwithstanding, if the rocket is not off the ground by September the 6th, the NASA team will have to roll the vehicle back into the VAB anyway for servicing and testing of the flight termination system, which is only certified for 25 days after the testing of that system. And that clock will run out after the September the 6th launch opportunity. And NASA officials have said if the rocket has to be returned to the vehicle assembly building, it would be very difficult to have the rocket ready to fly in the next launch period, which runs from September the 19th through October the 4th. So if a rollback to the vehicle assembly building is required, that would almost certainly push the next Artemis 1 launch opportunity into October. But we'll wait and see what NASA says, what the engineers determine might be the cause of this engine bleed issue, and what could be done at the launch pad. The teams will be assessing their options before deciding on a path forward. Before we sign off our live countdown coverage, we'll ask you one more time, if you want to support our coverage, you can become a member of our YouTube channel. We have different membership tiers that you can join at depending on which level you join at. You can gain access to exclusive video features on our YouTube channel, and you'll also be helping us continue and expand our launch coverage. Also, if you haven't already, please subscribe to our YouTube channel. And you can also like our YouTube channel to help us gain a wider audience for our launch coverage as well. And if you're a collector or if you're interested in space flight memorabilia, you can go to our Spaceflight Now store. That's shop.spaceflightnow.com. And there you can purchase mission patches. On the left, we have several related to this flight. We have the Artemis program patch on the top left. Below that, there's the Artemis 1 mission patch. And below that, we have an Artemis commemorative patch available for purchase in the Spaceflight Now store. That's at shop.spaceflightnow.com. So we'll have further updates on the status of the Artemis 1 launch on spaceflightnow.com, as well as on our social media channels. So follow us there. And we thank you for joining us for our overnight coverage of the Artemis 1 countdown. The mission did not get off the ground today. We'll stand by and await word from NASA on when the team may make another run at launching this historic test flight. Until next time, I'm Stephen Clark reporting live from the Kennedy Space Center in Florida. Thanks for joining us.